Alrighty, the gameplay ability system. We've got plenty of things to get into today to get started with, so let's get into it. First and foremost, we're going to go up here into plugins, of course, and we're going to look for gameplay abilities. You want to turn that on. You also want to check whether or not you have gameplay tags enabled. It should be enabled by default, but if for some reason you don't have it enabled, do make sure you also have this one, because the gameplay ability system makes use of gameplay tags a lot. Anyway, we want to restart the Unreal Editor and then we can actually get into it. Okay, so a few things before we get started. We are going to need to use a little bit of C++ to set certain things up which can only be done in C++. Just the setup will be done there, and a few of the more complicated calculations that we'll need to do eventually also are limited to C++. For the most part, this entire system is made to be used in Blueprint, and to make it easier for gameplay programmers who don't really know how to use C++ too much to quickly and efficiently make gameplay abilities for a game that needs a lot of them. If you just need a game with like a handful of attacks, it might be better to manually program that yourself, but it's still good to dive into how this works and just explore the options. That said, if you have a project that has been made and set to be Blueprint only, what we can do up here is we can still come up into tools and make a new C++ class that will then generate all of the code for you and start using C++ in your project. If you're entirely new to C++, please do go check out my C++ basics course. You don't need to follow it all the way through, but the first like 4 or 5 videos, just to know more or less what is going on the C++ level here, you will really kind of need that. Then, when we have the C++ enabled for our project, we can open in Visual Studio or Visual Studio Code or whatever you might be using, and we have our IDE ready. Coming down into source and then in your directory for your project itself, there should be a couple of ones in here already, like the third-person character. If you used the third-person character template, I'm assuming that you did. And then some other things as well. The most important thing here being your project.build.cs. This is one of the very few C# scripts that you're going to have using Unreal, because usually everything is C++. This is in C#. And what we need here is we have a public dependency modules.addRange. And this is just adding separate modules that we may or may not be using to allow the engine to access that kind of code. These are all the public modules, but you can also add private dependency module names. This is using GitHub Copilot. This is entirely right. We should be adding the gameplay abilities, the gameplay tags, and the gameplay tasks. When you've added these to the private dependency modules, you can also add them to the public ones. That will still just function. That is how I have it set up in my own project, but you should add them to the private modules. You want to either use live coding or just rebuild your project and open it up again. We're going to use live coding here because that is fine. And that will then allow you to actually start using the gameplay ability system. So let's get back into the engine here, because it's easier to navigate to different classes that we're using here. And what we're going to do is we're going to get our gas tutorial basics character. And let's open that up, which opens up the header file for that character. Now, we need to add the gameplay ability component through C++, because we're going to need to interact with it through C++ a little bit, and things added in Blueprint are more or less invisible to C++. In here, let's go into the protected section, and I'm also going to remove the look and move functions that we have in here, because I have those set up on my player controller that I made off screen, as well as jumping, and the entire player inputs will be dealt through the controller. This is just basic project setup. This is not specifically to do with gameplay abilities, but I just want to clean up a little bit of this C++ stuff. So we only have all of this left. Now, in our protected section, we're going to add a U property. And that U property will be, for now at least, of type added anywhere. We want Blueprint read only, so not read write. We want read only. We don't want to be able to write to this. And the category we'll put as gas for gameplay ability system. And then for meta allow private access, we're going to set to true as well. And of course, that is going to be something of type class u ability system component pointer, and we'll call that the ability system component. That works out fine for me. And then we'll come over into the CPP file, into the constructor of this class, and we'll just go to the very bottom here, and we'll say our ability system component equals create default subobject of type u ability system component, and the name of it is going to be the ability system component. In order for this to work though, we need to come up here into the includes, and we need to include the ability system component.h. Now let's head back to our header file here, because we're actually going to need to use an include in here too, which is quite unusual. Usually you try to avoid including things in your header file, but in this case we want to include a interface, that being the ability system interface.h. This is going to allow us to get an easy function to get the ability system components on this character from anywhere and everywhere very easily. And you can overwrite this kind of stuff. You can do whatever you want with it. You can, if you understand interfaces, you know what you can do with this. If you don't understand interfaces, just go along with this. Maybe watch my blueprint interface video specifically on that. It's very, very good stuff. Because with that header file included, we can now also, after our public a character, put a comma, and then we can include the interface. So that will be our public I ability system interface, which now we have access to the functions that live on that. So the one that we're going to be using will be the virtual u ability system component pointer get ability system component, which will be a const override, and that will just simply return our ability system component. Now, you can override this on different classes to do different things and return different ability systems. So for instance, if you have a class that for some reason is like a minion of a bigger enemy, and it doesn't have an ability system component of its own because it just refers to the ability system of its owner, like the boss fight or something, you can then override the function on that specific class to not return its own ability system component, but look at its parent and return that ability system component. So you can change the actual implementation of this on a case-by-case basis if you need to, which is the whole point of an interface. If you keep getting these errors like I am, what you want to do is you want to reveal this file in Explorer, and we can simply just generate Visual Studio project files, and it will regenerate some files. When you make new classes, sometimes Visual Studio, at least VS Code, gets a little bit confused. And with that, we have now added everything in here for our ability system component. So if you want to add an ability system component to your enemy actors, which we'll do in a moment as well, you pretty much do these steps to add it to those things as well. I also want to point out that I misspelled virtual and I didn't forward declare the U ability system component, which was kind of an issue. That all fixed now, we can compile and we should be able to see in the engine itself, we have our ability system component on our character now. And our default third-person character that we have here now has a ability system component, which we can get into all of the more detailed stuff about how we use that and how we actually do the stuff with gameplay abilities that we want to do a little bit later. But for now, suffice it to say, we have our ability system component and we can use this get ability system component function, and this can just be used on any actor. So if, for instance, I am in my level blueprint and I want to get player character, which will return a generic character reference, I can still use the get ability system component on that, and it will run the function that we've just overwritten in C++ and return us the ability system component on that character. So that is the reason we needed to set all of that up, because I have a couple of characters here that I downloaded from the Unreal Marketplace, from the Paragon selection, and these ones inherit from the normal character class. So we're actually going to change that to be based on the Gas Tutorial Basics character instead. And now you'll see these ones also now have ability system components. And it's trying to replace a couple of the components with other components, but that doesn't matter. So we got that, and I'll also go into the thing that we're eventually going to turn into the enemy that we'll be fighting, which all of this stuff is deprecated code, which doesn't work anymore. So we're going to just remove that. And then in our class settings, once again, we'll base this one on the tutorial basics character so that it gets an ability component. And for now, that means that we have our setup with our enemy, which is going to use that in its behavior tree eventually, and our main character, which now has access to abilities, system components, but there's one little issue there, and that is that it doesn't do anything yet. And that's what we'll get into next time. Next time we're going to get ourselves a HP and something like a stamina or a MP, magic stat, whatever you want to call it. Now that we have the ability system components set up on both our player character and our enemy character here, and I have fixed some compile errors that were unrelated to the gameplay ability system between videos, we can now get started with attributes. Because what are gameplay abilities for? Gameplay abilities are to apply gameplay effects, and gameplay effects will change attributes. That is the entire framework, that is the entire basis of how the gameplay ability system works. So a gameplay ability might be attack, which will play an attacking animation, and then when you make contact with your sword on an enemy, that will trigger a gameplay effect to take place, and that gameplay effect might be something like damage. That gameplay effect will be programmed to change an attribute on the target actor, in this case that will be enemy, to decrease its HP by a certain amount. You can make this as complex or as easy as you would prefer. Today we're just going to add some HP and maybe like stamina to both of our characters. So the way we do that is through C++. So you need to make your attribute sets, which are kind of like groups of attributes in C++. So let's make a new C++ class here and look for the word attribute, and we can make a attribute set. And if we click on next, we can say whatever it should be called. So let's call this something like basic attribute set. It will be something that we can pretty much give to any character, right? The enemies are going to need HP and stamina, but so will the player, and maybe so will some breakable objects. We can give that to them. You could even break this out into separate attribute sets, just one for only HP, so that breakable objects don't have a stamina, which they might not need, but sometimes it's nice to just have that second attribute in there to begin with. So let's create this class, and that will generate a new header file and a new CPP file for us. And here I'm going to do a little bit of copy pasting of some code, and you're just going to have to follow along with me, because here we start using some macros in C++. If you have to write out everything that these macros do, it's going to get even more mind-boggling, and you're probably not going to follow along. I know I wouldn't. So we have macros that the plugin gives to us that we can use to make our lives a lot easier. So what we do is we first define a attribute accessor, and we do that up top here above the class itself. So what this does is this just gives us some simple getters and setters for like the property names, and given it an emitter, given it an initial value on begin play. That will now happen automatically because we can define this through this macro. And these are just some of the basic functions. We'll get back to these in a moment when I'm talking a little bit more about the upsides and downsides of using gameplay attributes here. For now, what we're going to do is we're going to make some U properties for every single attribute that we want. So starting out with, we can just set this to public, and we can set a U property which will set to being blueprint read only. We don't want to write directly to this because that is what our gameplay effects are going to be doing. Those are going to be changing these attributes. You don't really want to change these attributes directly. You're always going to do this through gameplay effect. And then the category, we can just call this something like attribute. Now, part of the reason, and this is why GitHub is telling me to set something about replication, part of the reason that you might want to use the gameplay ability system is because it is very well built for having gameplay abilities like attacks and ranged attacks and all that kind of stuff working on network replication. So if you're making a multiplayer game, a multiplayer action RPG, a multiplayer something like a MOBA, for instance, which has a lot of different abilities that you can execute, the gameplay ability system will take care of a lot of headache for you that you usually have to deal with yourself when doing that kind of thing over a network. We are not going to particularly dive into the network replication part of things. I think it is important to first and foremost understand the very fundamental basics of how everything works, and then you can take a step back and look at, okay, so now how does that work on a network level as well? And then we declare the f gameplay attribute data with the name of our attribute. In this case, that will be health. And then we use that macro that we made up here, the attribute accessor, and we put in the class name. So that's the name of our attribute set, and then the attribute itself. Again, GitHub Copilot is doing that for me very, very intelligently. And this is how you set up a single attribute in your attribute set. So let's also, I'm going to call it mana, just because it is easier to type out than stamina every single time. But let's also make one mana. And now we have an attribute set which has health in it and it has mana. Now we want to give these attributes to our characters. So what we're going to do is we're going to go back into our tutorial basics character, the thing that last time we added the gameplay ability system components into. And in there, we're going to, in C++, also add these attributes. It's not going to be too complicated, but we want to add these in C++ as well. So here, we're also going to add another U property, and we're going to set this one to edit anywhere or edit defaults only. That doesn't really matter. Read blueprint only as well. The category we're going to keep in gas, and allow private access will set to true as well. This will be a const, meaning that as constant, it's going to be read only. We're not going to write to it because, again, that is specifically something that the gameplay effects will be doing. We won't be doing that directly. And we need to forward declare this. So this will be a class of type U basic attribute set pointer, and we'll call this basic attribute set. Something like that. Doesn't really matter what you call it, just make it something that is clear as to what it actually is. We'll move into the CPP file for our character here now. And in the CPP file in begin play, first and foremost, we're going to check is valid for our ability system component. It usually should be. There's no reason for it not to be valid, but it still is a good thing to check. Then if it is valid, we're going to get those basic attributes set. And that one will set equal to our ability system component, and then use the function called getSet with the template in here of ubasic attribute set. And what that does is it just initializes this attribute set pointer to have an attribute set given to it. So this is pretty much the equivalent of what you will be doing here in the constructor with create default subobject, but instead you do it in begin play for the attribute sets, and you do it with this function. So anytime you add a new attribute set to your character, you're going to want to also do this in C++. And of course, if we're going to do this, we also need the include that goes with that. So we need to hashtag include our basic attribute set.h. The attribute sets also need a include here for the ability system component, which has to do with the macros here for the attribute accessors. Those make use of the ability system component, so you do need those. And with all those includes added in, we should now be able to compile this thing, and I'll be able to go into Blueprint and actually show you how to access these properties and how you can work with them. So if we now go into our player character, we'll be able to see, if we zoom in a little bit here, we can get our basic attribute set. And from that basic attribute set, we can get our health. And the health, usually you'll probably be used to, if you have something like a health value, it just being a float. In this case, it is a struct. So let's break that struct. And that gets us a base value and a current value. And this is really where we get into the interesting stuff, because these attributes have a concept of a base value. So that would be the value that you would usually be at, but also a current value. So if you have a potion or maybe a curse on a object or whatever that increases your attack by 20% or maybe decreases it by 30% or something like that, you can actually change the current value of that without changing the base value. So for temporary boosts or nerfs to one of your stats, you don't have to then like cache that information somewhere else, because these attributes just keep track of a base value to begin with, which is very, very nice. They also have a concept of having a minimum value and a maximum value. You can't access those through here, unfortunately. And that is coming back to what I talked about before in these accessors. These macros don't set up for you to get access to the minimum and maximum value, and nowhere in the gameplay ability system native code does it actually use the values for minimum and maximum. It doesn't automatically clamp it to between those two. Then your base value will be the amount of health you currently have, and then your current value will be that base value, but after some calculations with maybe buffs and debuffs applied to it. Hopefully that all makes sense. So let's get a little bit more into setting these up, because if we go into our ability system component here, we can set a default starting data, and that has two members in it. The attributes itself, so we can set our basic attribute set, and then we can make a data table that has values in it for whenever we spawn in an enemy or spawn in a player or whatever, what are going to be their basic starting values. So let's for now, just in the content folder here, make a data table, which you can find in miscellaneous, and then in here we can find a data table, and I believe it is attribute metadata that we want to have. So we make just new table for now, and in this table we can add a couple of rows. And here it is quite important that you give the row names the proper corresponding names. So what you want to name them, this is not up for interpretation. You want to name them the class name. So in our case, it will be U basic attribute set, and then a dot, and then the name of the attribute. So that will be health for us. And then the second one would be mana. One very important last note here is that I just copied over the class name from the C++ class. You don't actually need to include the U in this data table. So you can forget the U, just everything after the U. The U is just a prefix that Unreal uses in a lot of its variable names. Like something is either a U or an A or a whatever. There's a lot of prefixes that they use. You can just ignore that for now. The name that you gave the class, that's going to be the thing that they're looking for. And this gets you those base values. You'll note that this doesn't have a current value because you don't really need to initialize that. But then it also has the minimum and maximum value. And as I said before, this doesn't really do anything by default, but this structure does give you the ability built in to set these minimum and maximum values and maybe do something with them, but you'll have to do that through your own. If you want to make use of that, just as a quick FYI, we're not going to get into that right now. We might go into a little bit more of that advanced stuff in the future. But as I said in the previous video, I really want to just get this setup out of the way so that we have this setup and we can go into Blueprint and we don't have to look at C++. If you wanted to do that, you would need to extend this gameplay attribute data to also include a min-max value, and then use that, and then add some functions to get those values out of there as well. For the most part, this can be really, really powerful, and if you're planning to use this on a bigger scale, I would really recommend that you do something like this and you do experiment with it a little bit. For the most part, what is actually probably the easiest way to go about doing this is to simply just make a attribute for max health and make a separate attribute as well for your max mana in this case. It's not the most ideal circumstance, of course, and you are better off implementing your own clamping system with the min and the max value that the opportunity is giving you to do, but for now, this will work, and this will get us out of the C++ a lot quicker and just be able to use Blueprint and get to work on the actual gameplay experience that we're going to be building here. Because I don't want to get stuck in C++ for too long. So with all that said, we can now set our new data table here. And that will take this attribute set and look up in this data table, hey, is there any attributes that match anything in this set? If so, we're going to use the information from here to set that. So let's set the base value of both our health and our mana to being 100 for now. And let's actually add in our max health and max mana as well. And we'll set both of those to 100 as well for the time being. Again, this is a bit of a roundabout way of doing it, but it is the most straightforward and easiest way to do it. Once you get used to the system as a whole, you have every opportunity to dive back into the C++ side of things and start working with using this min value and this max value if you really want to. For now, I will just show you in event tick, if we get our basic attribute set and we get our health, and from that we can get we can just split that structure pin. We don't need to use the break node. We can also just split structure pin, and we'll just print string and we'll print out our base value. And you will see now that on initialization I have 100 health because that's being printed out. And that's where we're going to leave things for right now. So we have the ability system component set up. We have health attributes. We have mana attributes. We even have max health and max mana in a bit of a roundabout way, but it will work fantastically fine. Trust me. So I think next time it's finally time that we dive into gameplay effects and see how we can manipulate these things. Either on ourselves, like using mana to attack, or maybe otherwise on an enemy so that we can damage that enemy and how to drive that damage and all that kind of stuff. Now that we both have ability system components and attributes on our characters, we can start manipulating those attributes. So as a bit of a recap, what we have is a character here with an ability system component that has an attribute set to it for basic attribute set. We're going to probably make more attribute sets as we go along. And that's then being set through this data table to its initial value. Now, let's make something real quick, real easy that will use up some of our mana whenever we try to attack. Because we have this Paragon character, which has some attacking built into it, right? These are not gameplay abilities. We haven't made gameplay abilities for these things yet. And in the next video, we will be replacing these with gameplay abilities, but for the time being, we're just going to keep it at playing these animations, but we're also going to be using some of our own MP. So this is the basic setup that they have in Blueprint for the Paragon characters, which is a little bit messy, but it works. So what we'll do here is, after playing the attack, we will just simply decrease the mana on our character and then print out the new value. So what we'll do here is I have the attribute set that we had. We were printing out the health value. Now we'll get the mana value instead. And we will print the base value from that. If you're confused between what the base and current value difference is, I do highly recommend you watch the last video. So for testing purposes, let's just hook these three all up to our print string here. And now this is going to print out just 100 every time we try to attack, because we are not yet decreasing the amount of mana we have. And let's see, maybe we can simply just subtract 20 from this, and maybe then we can set the mana. No, we cannot. That's not how that works. If you've seen the last video, you would have known that's not how that works. We cannot directly influence these gameplay attributes. We need to do that through gameplay effects, and that is where the cool shit comes in. So let's make ourselves a gameplay effect. You make those through Blueprint. Finally, we are here in Blueprint. Right, we've done a lot of setup in C++. We can get into the exciting blueprints. We can make a gameplay effect. And there's a couple of classes here, like the gameplay effect calculation, execution calculation, custom application requirement, all that stuff we might get into in the future. For now, we simply want the gameplay effect, and we'll call that gameplay effect use mana. Anytime you want to change anything about any attribute, you're going to have to make a specific gameplay effect for it. So let's open this up and see what this looks like. Because there's no events here, there's no functions to override here. Gameplay effects are literally only just a list of instructions that you do through this UI. So this is where we move from, okay, we did a lot of very code heavy stuff in C++, but that is all to be able to use this system, which is very designer friendly because it's all happening right here inside of a UI. So we have a duration policy. This can be instant or infinite or over a certain duration. So instant just happens the moment the node that applies this gameplay effect takes place. Whatever we put in here will take effect. We can also set something to infinite or has duration. Well, has duration is pretty straightforward. It has a duration, and this is just how long that duration lasts. So something like 50 seconds, right? And you'll note that when we set this to has duration, we get the period here. And this is how often this thing will trigger itself while it is active. So if we have like a regen spell, 50 is maybe a little bit much, but a regen spell that lasts for 10 seconds and heals us every 2.5 seconds. That's how that would work. You can set a gameplay effect that has a duration, and then over a certain period, it will trigger itself over and over again. There's a bool here to say whether or not it should apply itself immediately as well. So if you have a regen spell, maybe it heals you once and then 2.5 seconds later again, 2.5 seconds later again, 2.5 seconds later again. But maybe you don't want that because that would undercut your normal healing spell a little bit. So what you want to do is set this to disable so that it doesn't initially do the healing effect, only start doing it after the first 2.5 second count. And then we also have infinite, which is just the same as the has duration. It does the effect on a set period, but it doesn't have an end. You have to explicitly tell this gameplay effect to end, otherwise it will just stick around forever. We're going to stick with instant here because this is just using up some mana. So the moment we attack, we want to use up some mana. Here we get into the modifiers or executions. Modifiers are what they sound like. They modify gameplay attribute. Executions are kind of like modifiers on steroids. So a modifier can, for instance, not take in multiple gameplay attributes to calculate something to then modify the health on your opponent. So if you have a strength stat and they have a defense stat, and maybe you both have like something else going on that will influence that as well, a modifier won't be able to deal with that. For that, you'll need to make an execution calculation, and that's something we'll do towards the end here because that's something we need to do in C++ again. So for now, we're going to stick with modifiers. These are just the more simple executions of, hey, just add something to this attribute. Hey, just remove a bit from this attribute. Maybe multiply this attribute by something, right? So we will modify our attribute that we can choose here. And this gets us the drop down, which has all the attributes that you've made in all your attribute sets. So if a ability system component that you're trying to run this on doesn't have this attribute, it's not like your game is going to crash or anything. That's all built in protection. It just won't do anything. So for now, we're going to set the attribute set mana, and we're going to choose the modifier operation adding. And you might think, but we want to subtract. There's no subtraction because subtracting is just adding a negative number. That's just how math works. But we can multiply or divide or override or invalid. I personally don't know what invalid would be useful for, but sure. Overriding, of course, is just setting a new value directly. Dividing and multiplying, I don't think I need to explain to you. Then we get to the modifier magnitude. And this is, for now, we're just going to set a scalable float of using 20 mana every time we do this. But you can also do this based on an attribute. So you can say the attribute that we want to use is going to be, for instance, our health for some reason. So we want to subtract the amount of health we have from our mana. In this case, that doesn't make a lot of sense. But let's say instead what we want to do is we want to subtract the amount of strength that a certain character has from the health of another character. That you can do through this attribute method. Because here we have the attribute source and target as well. So the source will be the thing that is applying the gameplay effect. This will make a little bit more sense in a moment. If you're not following along, don't worry. But it also has a target, obviously. So in this case, we could say, hey, the source, get the strength stat from that and use that to subtract from the health of the target. And that is how you would set up a basic like combat system. You can also add values pre or post multiplying, and you have this coefficient, which is the multiplier of this specific effect. So if you want to have an attack that, for instance, does twice the amount of damage compared to a normal attack, you would set this to 2, of course. If you want to have something that does a negative amount, because do remember, our modifier operation isn't subtraction, it is adding. So if we want to deal damage, it has to be -2 or -1. Then we also have custom calculation classes, which you can code in C++. Honestly, this option doesn't come up too much for me. Usually when I feel like needing to do something that requires this, it very quickly goes into me needing an execution class and not just a calculation class. So it's nice that this is here. We're probably not going to even bother covering it. And then we can also set by color, which we might get into in a moment as well. But this allows you to make a gameplay effect in Blueprint and set its value of what it's going to need to change. So for instance, setting the damage through Blueprint. And then you can set by color, and this requires a tag to be passed in so that things can be matched up properly and stuff like that. We might cover that as well because it is useful. For now, we're going to stick with scalable float, and we're just going to subtract 20. So what we want to do is we want to add -20. Then we have executions, which again, executions are more or less just more complicated modifiers, and we have conditional gameplay effects. So this can be a gameplay effect that is applied by this gameplay effect. If we have a gameplay effect that is, for instance, a burning sword attack, right? When you get hit by a burning sword, instead of that ability applying both a burn and a sword-based damage, what we can do is we can make this specific gameplay effect that we can just apply once, and then this gameplay effect will deal damage once, and then also add in the burned gameplay effect onto our targets as well, which is very, very nice. Sometimes you want to use one, sometimes you want to use the other method. You have both available to you. We have a chance of applying it to the target. So if you have something like a confusion spell and it only has a 30% chance of hitting, this is where you put that in. So this is just an accuracy. And there's a few more things that we can talk about here, most of which have to do with gameplay tags. I kind of want to make a video specifically about gameplay tags because at this point I'm already probably overloading you with a lot of information. Again, if you're not following along, when we put this into practice, you're going to be fine. For now, just suffice it to say that these gameplay tags, we can grant tags or check tags on the actors that we're trying to apply these things to. So for instance, we can give this asset itself a tag. We also have granted tags, which means that it will either add or remove tags on the actor that this gameplay effect is being put on. And this can be very useful because, again, if you have a status condition like burns, you can just say when this gameplay effect applies, we add it to you. And when this gameplay effect is removed, it is then automatically also removed again from that actor, which is very, very nice. But again, we're going to get into the whole gameplay tags a little bit more. For now, suffice it to say, there's a lot of information here that you can play with, and it is very overwhelming at first. But the wonderful thing is, because there's so much information just in drop-down menus here, you don't actually need to do much coding from this point on. You just need to navigate these menus. So now that we are back here in our blueprint, what we can do is we want to get our ability system component, and we can apply gameplay effect. And here we can apply the gameplay effect to ourselves or to a target. And this is what I meant before. If we want to apply it to a target, we first, and this is just kind of badly designed because the target up top here is the target for the node. So this is the thing that is executing whatever this node is. That's just the same way every other node also has a target. Like if we have a destroy actor node, that also has a target, right? But then we also have the actual target of this. So this really should be called source, and this is the target. So this gameplay ability system component will be applying a gameplay effect to another gameplay ability system component. And that is where we come back to what I showed you before, where if we use this attribute-based stuff, we can choose between whether or not we want to take an attribute from the source or from the target. That is where that comes in. But you can also apply gameplay effects to yourself. So apply gameplay effect to self, and that doesn't have that target in there. We only have one gameplay effect at the moment, and that is use mana. So let's connect all of these up through here, actually. And now, every time I use an attack, my mana will go down by 20 and will print out the new amount of mana that I have. So let's test that out, shall we? This is 80, 60, 40, 20, 0, minus 20, minus 40. You might be seeing a bit of an issue here. And that is because we're just directly applying a gameplay effect to ourselves without any checks or without anything at all, really. So this is not the ideal way to do this, but I just wanted to make a video going over all of the theory and all of the options that gameplay effects offer you and how to put them to some basic use. It's really hard to really use gameplay effects to their fullest without implementing them within a gameplay ability, and I want to make the next video more specifically about gameplay abilities without having to explain all of this mumbo jumbo that we've gone through today in here. So hopefully this entire information dump hasn't fried your brain too much. If it has, I do recommend to just jump into the engine and experiment around a little bit. Listen back to this video 2 times, 3 times more if you need to. And without touching gameplay abilities yet, just play around a little bit with increasing and decreasing a stat or, well, an attribute on your own character, just to get a bit of a feel for it. Next time, we're going to get into a lot more of those things that we talked about before, like using attributes from your enemies or from yourself on your enemies, and that's where this stuff becomes really, really powerful. Now that we have our ability component set up, we understand gameplay attributes and we understand how to influence those through gameplay effects. Today we're going to get into gameplay abilities. Because usually the way things go is we have our attributes which are being impacted by effects, and that is generally done through gameplay abilities. It doesn't have to be, but in general that is the way this is set up to go. And a gameplay ability could be literally anything, more or less. It doesn't have to be something like an attack or a special move or whatever. It could be something like taking damage and getting knocked back. It could be something like jumping, for instance. All that kind of stuff, anything that is an action in your game, you can make into a gameplay ability. So let's just get into the basics of it today, because this is the entirety of what this plugin is all about, is being able to create gameplay abilities very easily here. And everything else we're going to be doing throughout the rest of the series is going to be centered around this. So for now, let's just get into the basics and make a blueprint of type gameplay ability. And when we scroll down here, we can see there's already a gameplay ability montage and a gameplay ability character jump, which is one of the examples that I just gave. So let's make a clean gameplay ability and call this gameplay ability, for now we'll just call it test. And when we open this blueprint up, you can see that instead of the usual begin play, begin overlap and all that kind of good stuff, we have our activate ability and our end ability. So whenever we activate an ability, of course, it's going to come through this event, and then we can do whatever we want. And at some point we have our end ability. And whenever we run this function, we end the ability. So the ability becomes non-active, and whatever we put into this event runs. So if we need to do certain things, reset certain stuff when an ability ends, we can do that through this event very easily. Now, what you usually want to do with most gameplay abilities before you do anything is we want to commit ability, is what this is called. And this tries to spend the resource that is linked to your ability, and we'll get into that in a moment, and I'll probably make a separate video on that. And if this succeeds, we get a bool out of this, whether or not the commitment really succeeded. So we can check, for instance, if we're doing a spell that costs 20 MP, it's going to try to spend that 20 MP. It's intelligent enough for itself to not go into like negative values or something like that. And if you have more than 20 MP, it will subtract that from you and give you a true value here in the bool, and you'll be able to keep on going. If you have less than 20 MP, this will return false, and we can just instantly end the ability. And you'll see that this will create a path throughout the ability where we, at multiple points, probably end up ending the ability in different ways. For now, let's just make an ability that triggers a simple attack. Next time we're going to go into this and actually make some damage dealing stuff as well, but for now we just want to trigger a simple attack. So what we can do there is we have a bunch of different options for tasks that we can do. So if we go here and we look for tasks, we have the ability tasks, and we can apply root motion with a constant force, apply root motion with a jump force. So this is just moving toward a point with a certain force. This is acting like a jump, you might think, but the character movement already has a jump. And there's two reasons that you would use this, because number one is this just applies root motion to any actor that's going to try to use this ability. So even if something doesn't have a character movement component, if it's just a normal pawn that doesn't have that component, you can still use a jump force. So we can say the distance that it should jump forward, the height that it should jump, the duration of how long that jump should last. We can give it a rotation, a certain velocity when it finishes. We can do a lot of stuff here. And this is where things become really interesting, right? Because we've got this pin up here, and this will just execute the next node right away. But because this is an asynchronous node, which you can see because it has this little clock over here, it also keeps track of these two outputs here. So when it is finished or when it is landed, those could be two different things. Oftentimes those will be the same thing. You even have a bool here, finish on landed. It will execute different stuff. So if we have an attack, for instance, that has the character jump up and then fall back down, and when it lands, it creates a shockwave, for instance. We can just apply root motion, jump force, and then on landed, we can spawn in like the particle effect for the shockwave and the collision box for that shockwave, and so on and so forth. And that's why the tasks here come in really, really handy. You can make your own custom tasks if you want to in C++. We won't really be delving into that too much because the tasks that Unreal gives you by default are really, really good as well. So let's go back again and check what other tasks we have here. So we can apply root motion with a constant force. We can apply root motion to move to an actor. We can move to a location. We can play a montage, which is an animation montage, and wait. We can repeat an action. We can spawn an actor. We can start ability states. We can wait confirm, which I believe is an input related thing. I'll make a separate video on that as well. We can delay a certain thing for an amount of time, which is just similar to the normal waiting node. But here we can also, instead of just waiting and then moving on with the rest of the code, we have two pins, one that executes immediately and one that executes when the timer finishes. So all these task nodes are really, really flexible to program in things like timing and different timings and different events happening simultaneously. That's what these gameplay events are really, really good for. For now, let's just apply root motion, constant force. So what we'll do is we'll, in the direction that we're facing at that time, is we'll apply a certain root motion force forward for a certain duration. And the way we get the world direction is by getting a reference to the actor that is doing this ability. And we've got a specific node for that, and that is get avatar actor from actor info. This just gets you a actor reference to the actor that is executing this ability. So this can be very generic, right? Because this is now a thing, an ability, that doesn't have, at least not yet, any hard references to any class whatsoever. So now this ability can be used by either the player or by an enemy. The only difference that's going to happen is eventually we'll need to play an animation montage and we'll make that into a variable, so we can set it to be whatever animation montage we want, and that way the code for this can be reused for a bunch of different types of actors. So we'll get the forward vector for the actor, and we'll say for now, we'll just have to test this out a little bit, say strength is 100, and the duration is 1. I don't know if this is a good number or not. I guess we'll figure this out at some point. Then this stop pin we can use to execute some more code immediately. So we can say, for instance, our play, montage, and wait task, which allows us to play, for instance, a dashing animation. I don't know that this character that we are using has a dashing animation. We'll look into that in a moment. And then we have this uncompleted, or when it starts blending out, or when it is interrupted, which is always a possibility, or when it is cancelled. We can all do different things, or we can all do the same thing here, which is end ability. So as it stands right now, this ability is just a dashing ability. And let's say when the ability ends, we want to print out a string, just so that we can see that the ability ended. If we go into the class defaults here, we can give the ability tag, and we can cancel other abilities with a certain tag when this ability activates. Or we can block other abilities from activating based on their ability tags while this ability is active. So for instance, if we're doing a dash, we don't want to be able to attack while we're dashing. We can say, for instance here, we don't have our ability tags set up at all yet, but we can add a new gameplay tag, and we can call that something like action.attack. And if we add that new attack, we can say, okay, so we don't want to be able to use action.attack based abilities while we're doing this. And then for the ability tag itself here, what we can do is we can add a subtag to actions, and we can say action.dash, adding that new tag as well. Now the engine can easily keep track of, okay, so you are dashing because you have an ability active with action.dash, and if I'm trying to do an attack, you won't let me because I'm blocking any ability with this tag in it. Then we also have the tags to do with the owner. So these are the tags to do with the abilities themselves, but we can also say, hey, as long as this ability is active, I want the owner of this ability to have a certain tag. So we can say, in this case, make an ability tag and call this status.invincible. And that means as long as we're dashing now, we will be invincible. So this is the way you can make things like a dodge roll, for instance. In much the same way as the ones above, we can also say, okay, in order to activate this ability, the owner needs to have a certain tag. So if you have like a desperation move kind of ability, which only is allowed to be used when you're under a certain amount of HP, you can give your player, or any enemy for that matter, that tag only when they are under a certain amount of HP, and then only can they use this ability. On the other side of that, we have the activation blocked tags, and that means that this cannot be used when the owner has certain tags to it. So if you have a enemy that like curses you and this allows you to use magic, for instance, if you have the status.cursed tag, which you would have to make, then you can't use this ability when that tag is on your player. Now we get into source and targets, and this is because not always will you activate abilities on yourself. Sometimes you will try to activate an ability on something else. So in that case, we also have opportunities to say, hey, when the player is trying to activate an ability on an enemy, we can check either the player for having certain tags or that enemy for having certain tags, taking into account which one is the source and which one is the target. Whereas these activation ones, they don't really care about that. They just care about the thing executing the ability. So that's what all these tags are all about. It's a lot of information, as you're used to at this point. There's a lot of upfront information about this. Just wanted to show you this. These top ones are the most used ones. The further you get into the bottom here, the less useful they become, but it's good that they're there. Now, the two things that I really wanted to talk about here is down here, the gameplay effect cost. So when we added this commit ability node, I explained that it's going to try to use up some resource in your attributes, and if it is able to, this bool becomes true, and if it's not able to, this bool becomes false. It's as easy as that. This gameplay cost is the way we do that, through a gameplay effect. So we can make a gameplay effect, and we already have one, in this case, use mana, which we made last time, and use mana just takes your mana attribute and subtracts 20, as easy as that. So now that we have that gameplay effect set to that, we will try to use 20 mana, and if we can, it subtracts it for us and then does the ability. We also have a cooldown gameplay effect, and that is just a gameplay effect that will be used for, well, cooldown on an ability. So as we saw before, we have this duration policy on gameplay effects, and if we don't set that to instant, but instead to has duration, I suppose you could also use infinite for this and manually toggle it back off at some point. But for the most part, for cooldowns, you want to make a gameplay effect that has a duration, and then you can use the duration down here, the scalable float magnitude, for how long of a cooldown that ability should have. So if your ability, for instance, should only be allowed every 5 seconds, you just make a empty gameplay effect that doesn't really do anything else, that just has a duration of 5 seconds, and that's a good way to make a cooldown. For now, I'm not going to bother with that. All that said, a lot of that is side information, not relevant for what we're doing right now at the moment. Just this is probably the best moments to go over all that. We've made this dashing ability now, and with this we can't use it yet, because if I go into the gameplay, like, how should this be used? When should this be used, right? This is just a set of instructions for what the ability should do, not how it is triggered. And that is because we do that through the specific characters, whether it be through like an AI behavior tree or through your character blueprint. So let's open up our character blueprint. And here last time we had a way to like use up MP whenever we try to attack. Of course, this was just a temporary way to show you how gameplay effects and attributes work. The way I showed you in this video, using the commits ability inside of a gameplay ability, is the way we actually do that. So let's get rid of this for now. Here is where we start to execute the ability. So we're going to get back into this in a moment, because this is the setup that the project comes with whenever you use a Paragon character. It's got a very simple setup where it just like plays some animations, and it has a simple counter here for the attacks. We're going to just replace these with gameplay ability instead. But for now, we don't have an attack yet, we only have a dash. So let's add in just a left shift. If you're making a real game, you would have the advanced input system, and you would be mapping these to input actions rather than directly to keys. I'm not going to bother with that for now. This is not a tutorial on the advanced input system. So when we press this, we want to, with our ability system component, try and activate an ability. So we can activate an ability through a ability handle, which is not what we're going to be doing right here, right now. But we can also activate it by a tag or by class. So we gave our ability a tag, and using that tag, we can simply, if we like make literal tag container, we can say, okay, just use an ability with action.dash. And then it will look whether or not this character has access to any abilities with action.dash as a tag, and then use one of them. As far as I know, it doesn't use them randomly. It uses just the first one it finds. So it will always use the same one if it's got multiple, which is a little bit annoying. If you wanted to use a random one, you have to do a little bit more trickery. And the way you would do that, and the way I generally prefer to do it, is just try activate ability by class, because this gets you a menu of all of the ability classes that you have in your game. So let's use our gameplay ability test here, and it will just try to activate that ability. And if you want to activate a random one, you make an array with random abilities for dashing, and you just pick a random entry out of that, and that's just basic programming. When we do this, you think, okay, so now it will try to activate that ability, and we will do a dash. And you would be mistaken, because the character still doesn't have the ability, is the issue. You need to grant abilities to specific characters in order for characters to be able to execute that ability. Otherwise, every character in the game would have access to every ability you've created, and that's probably not something that you want. So what we'll do is we'll add a begin play event here, and in the ability system component, we will use the give ability node, and there we can give the ability class that we want to grant to our character. So the way I generally like to do this is to make a variable and call it something like abilities on start. And we'll make this a gameplay ability class reference. So that way, and we'll make it an array as well. So that way, if we just compile this, we can add a few different abilities here. For now, that will just be our gameplay ability test. And if we put a for each loop in there, we can just loop through however long that array is, and we don't need to go through and add more and more and more nodes every time we want to grant an ability that the character just has by default. This is just the easiest way to grant a bunch of abilities right off the bat. If you want to grant some more abilities during gameplay, like if you have an ability shop, for instance, you will have to keep track of that in some way, like in the save file. And when you reload your save file, you have another array, which then grants a bunch of abilities. And a lot of that comes down to like more individualized project by project basis, how things make the most sense. Like for my game, for instance, the abilities that you have are based on your weapon. So I store simply those classes, references to those classes, on the weapons themselves. And when you switch out a weapon, it first gets rid of all the abilities that correspond to that weapon, and then it switches to the other weapon. And that weapon, whenever it gets equipped, grants all of its abilities to the player. And then when you get rid of that weapon again, it takes a look at, okay, these are all the abilities that I grant, so I'm going to take those away because you no longer have me. And then the next weapon does the same, and so on, and so on, and so on. So that's a very individualized project-on-project basis. Just figure out a good way to do that yourself. Now, abilities can have levels, and they have input IDs. The levels are pretty self-explanatory. You can use these levels to impact gameplay effects and have them be more effective. So if you have a fire spell, you can say, okay, grant this spell to my character at level 3, and then the gameplay effect calculation can use that level input to multiply damage, for instance. So if you have level 1, you might do like 10 damage. If you have level 2, you might do 20 damage. Level 3 does 30 damage. That's a very linear scale. You can use that level in your calculations however you like. But now, on begin play, we're granting this ability, and then when we press left shift, we are going to try to access that ability and activate it. So let's give that a shot, finally. So we can see on the top left corner, the ability is executing a few times. At some point, it stops executing because I don't have enough mana anymore. It doesn't really work, is the issue. And that is probably because the strength of 100 is probably just simply too low. So let's put that up to like 2500 just for testing purposes. This might be too high. Oh, there's an issue because we don't have any montages that play. So it immediately ends the ability, and when it ends the ability, it also cancels any tasks that are present at the moment. So let's just take a look whether or not we have any montages that we can use for something that is a little bit like a forward dash. There's not a great animation for what I'm trying to do here, but it'll do. So we have the E ability throw. If we browse to that asset and make a montage of that, we at least have something that we can do here. So now we'll see it moves us forward and tries to do that animation. It moves us forward a lot because I set it to 2500, of course. And this is just like general gameplay programming. You're going to do a lot of troubleshooting. So let's set this to 500 instead and see what that feels like. Over a duration of 1 second, that might be a little slow. And also we don't have in the animation blueprint the slots for that animation montage. So let's add a default slot at the very end here. So we actually display the animation. If you're not familiar with animation graphs like this, I have a basic setup tutorial for like state machines. This is a little bit more complex than that. I will be making more future tutorials about those kind of things as well. Now, to make this into more of an attack, what we can also do is when we finish applying the root motion, we change the montage that we're playing. So we do that one montage in our movement, and then when that movement finishes, we play the actual attacking montage. So that will for us be the melee A montage for the time being. Again, you would probably make both of these into variables so that you can easily reuse this and make different gameplay abilities by just simply changing out the animations. So if we like promote both of these to a variable, we can say this is the dash animation and this one will be the attack animation, and we'll both of those expose them. So if we make children of this, we can just simply change those animations. So this animation will then get interrupted after this movement is done, and it will play this animation instead. Now, one thing to be aware of in this specific case is that these do not apply to the same slot. This one only does upper body animation, and the other one was in the default slot, so that might get overwritten. So in that case, what we'll also do is we just want to stop montage before we play the next. That's just a little bit of security. If you have something weird going on with like different animation slots or whatever, we just stop whatever montage we're doing before we put in the next one. And now we'll see, we'll dash and then do our attack. The dashing animation is weird because it also looks like an attacking animation, of course. So for now what we'll do is we'll just go into the dashing animation and simply clear that out so that we don't have any animation with that, because we don't have a dash animation apparently. And with that we'll see that we have half a second of dash and then he does a swing attack. So that's the basics of setting up a attacking ability, and from there we can very easily go back into our content, and now we can change the name for this to gameplay ability base attack, and here it's as easy as just making a new child blueprint class, and let's call this gameplay ability hero attack 1. And when we open that up, we get an entire event graph in which we can add some more functionality if we want to. But for the most part, what we want to do is just in the class defaults, we can now set the dashing animation to whatever we want and the attacking animation to whatever we want. And this is very easily applicable to our hero, but we can just do this same thing and just put in the animations for our villains as well. And then the same gameplay ability can be reused for multiple different characters, and they all work exactly the same anyway. They can reuse the same gameplay tags, or maybe you want to have specific gameplay tags for specific types of attacks, which you can also independently on each individual basis change here if you want to, and so on and so forth. So that is the basics of how you set up a gameplay ability. Really, really neat. The only issue is, you might be thinking, yeah, but this doesn't do anything, right? So if I use this attack against this enemy over here, it doesn't do anything. Like, I can attack him, and it looks cool, but it doesn't really do anything at all. And I don't have any, like, homing either, so it's really iffy to actually hit him with this. And he doesn't stop when I get to him, and all that kind of stuff. All of that is details for now. That's all things that you can program in if you want to. Next time what we'll be doing is we'll actually be dealing with damage, because we'll be talking about gameplay events. So last time we talked about creating gameplay abilities, and we made this very simple like dash and attack ability, which ended up taking quite a while. This doesn't even deal damage as a result of that. So that's what we're going to be talking about today, is we want to be dealing damage. Now, we have this entire setup here, which applies root motion, it plays a dashing animation if we have one, we don't, and it plays the attacking animation, and then it ends the ability when the animation is complete. But after it starts playing the animation, and before the animation ends, we want to check whether or not our weapon is overlapping with an enemy. And if it is, we want to damage that enemy. So what we'll do with that is we can wait for a gameplay event, which we'll do immediately after we start playing our animation montage. Here we can say a simple tag that we want to be waiting for. So we can say make a new tag, and I want to make a tag called event.damage. You don't necessarily need to call it event.damage. You can just call it damage or player.damage. You can call this whatever you want. I like to make a specific parent tag for all my events to just keep things organized. So we can add that new tag there, and that we have as the tag that we'll be waiting for, event.damage. We can set this to only trigger once, and if we do that, during this gameplay ability, we'll only be able to damage things one single time. So if you have a sword slash that might overlap with an enemy, then not overlap, and then overlap again, that would deal damage twice. This is a quick and dirty way of preventing that, but do be aware that that also means that you can not damage multiple enemies with one strike, because as soon as you've done this event one time, it's not going to allow doing it again until you do the entire ability again as well. We might get into some more deeper stuff about how to keep track of the enemies that you've hit and checking whether or not we want to like send gameplay events because of that. That's a little beyond what we're doing right here, right now. So we're going to just set this to trigger once and ignore everything else. Then when this event is received, we get a payload with it. And I'll show you in a moment what that payload is and how we can set it up and everything like that. But for now, let's just break the gameplay event data to get all of the information out of it. So we've got the event tag, which will be event.damage in our case. But we also got the instigator, which is the character that sent the gameplay event through. We've got the target, which is the thing that we're targeting, which in this case will be our enemy. Then we've got the optional object 1 and 2, and these are just here for you to send through information that isn't usually contained within the struct, because we've got like instigator tags and contacts handle and all these other things. But you might want to send through something else as well, like the armor color of whatever actor you're hitting. And you can put that in a specific object, and you can pass through that object. Then in here, we want to cast to that type of object, and then we can get that information back out again. Honestly, I don't really use these optional objects all that much, but it is nice that we can send through pretty much arbitrary data in whatever way we want through these optional objects. So we're going to get the target gameplay ability system component, get ability system component, and to that we're going to apply effect to target. So the target will be that gameplay ability system component, and then the thing that will be doing the execution of it. It's kind of annoying that it has two pins called target, because usually a node has pins called target for the thing that is executing that code. But this also has an actual target. So the top target is the thing that will be executing the gameplay effect, and the bottom pin here will be the thing that is receiving that gameplay event. So we'll be using the instigator, which in all cases really should just be the same thing as our avatar actor here. So as a matter of fact, you could very much just use this as well, the ability system component on that if you wanted to. That would work entirely fine. And we'll apply that gameplay effect on event received. And the gameplay effect that we'll be applying will be like a damaging one. So that's just very similar to what we've made before here. Gameplay effect use mana. We'll just copy that over and we'll say gameplay effect deal damage. And for now, we'll just change the attribute set.mana to basic attribute set.health. We'll get back into this in a moment, because at the moment this will just always deal 20 health damage, which is less than great. We can use this sets by color, and that will allow us to set this custom based on each use of it, which is very, very neat. But that's something that we'll get into in a moment. Maybe in the next video, depending on how long I take in this video. So now our gameplay effect is set up to deal damage to whatever we're hitting. But we need to send that event from our character to our gameplay ability. And this is where things get a little bit more tricky. So if we open up our character blueprint here, we will want to add some collision boxes to these weapons first and foremost. So we'll do that. We'll add a box collision, and we'll add that to a parent socket. And we open up our skeletal mesh here to find out what socket we want to parent this to. So the sockets are called weapon _L, and presumably there's also a _R for that. Coming back, making sure we have our box collision selected here. What we want to do is we want to select this, and we'll just type weapon underscore L, and that sets that to be parented to the weapon socket or bone. And from there we can fairly easily just make the box extend whatever we want it to be, and we can drag it over to roughly be over the blade of our weapon. It's okay if the box is a fair bit bigger than the actual blade itself, because in general we want to have a situation where we give the player the benefit of the doubt. Like if it just didn't connect, we want the player to feel like, oh, that connected, that's really, really good, rather than it being a little bit too small and the player like, oh, but that definitely connected and we don't actually do any damage. That would be very, very annoying. So then we copy over that box again, and this time we're going to parent it to weapon underscore R, where we will pull this up a little bit more toward this blade instead. You probably want to pause the animation for this, by the way, if you're doing this, which you can do by selecting the mesh and then going into animation, advanced, and we can pause animations. That will pause the animations in the viewport and allow you to drag these boxes around a little bit more easily. Once the boxes are in place, what we can do is we can just deselect pause animations, and now we've got damage boxes on our weapons, which by default should not be doing anything. So generate overlap events should be off on both of those. And there's a bunch of ways to enable and disable these during the animation. You can make a whole function in a animation notify state, which is the most optimal way to do things. But for the time being, what we're simply going to do is we're just going to make two animation notifies here. So we'll just do a right click, maybe even a little earlier, like right here. We say animation notify, we'll make a new notify, and that is turn on, I think this is the right axe, and it swings through all the way down there, and we'll make another notify here, and that will be the turn off right. And we don't really need to worry about the left axe because we're not using that at the moment. Just for ease of use, I'm going to call these right box and left box, so I can actually easily keep track of which one is. So this way we fire an event at this point to turn it on and at this point to turn it off. And those events will now be accessible through our animation blueprint for this guy in the event graph. So we can simply say, like if we type in axe, we can see the turn off axe and turn on right axe here. And we'll use the try get pawn owner node and just simply cast that to whatever the hell this is called again, Chimera player character. From there, we'll get the right box and set generate overlap events to being false when we turn it off, and we can copy this entire thing over, and we'll set generate overlap events to being true when we turn on the axe. Again, you can make this a little bit more optimal by programming a animation notify state, which pretty much just does this, but it allows you to easily move these things around in your animation timeline. Do look into that if you're interested in it. For now though, I'm going to just do it this sloppy and easy way. Back in our character blueprint, we'll go into the event graph now. We'll select the damage boxes and say overlap, and we can just use the event overlap if we wanted to, but we can also use the component overlaps if we have multiple damage boxes that can overlap for whatever reason, or if you want to have different effects for the left and the right one. For the time being, what we're going to do is we're just simply going to use the actor begin overlap. The only two things that actually can overlap anything are the damages, so we'll be fine. But do note that you can do this on each individual damage box. And here, finally, we'll simply send a gameplay event to actor. So we'll be sending this to ourselves. So we can just set get reference to self as the actor that we'll be sending it to. The event tag will be matching with the event tag that we put in our gameplay ability. So that will be event damage. So we'll just check we want to get event.damage for the tag, and then the payload we will make gameplay event data. We can set the event tag to event.damage as well. It's not entirely necessary to do that, but it's good to just have that information properly in there. Then the instigator will be ourselves as well, and the target will be the other actor. And here you can see we can put in other optional objects which have any arbitrary data in them whatsoever. And again, we can then access that arbitrary data that we've sent through with this event in our gameplay ability, and we will have to cast to whatever type of object that we put in there. And this is quite simply as easy as it is. So now what we'll do, just to show this off a little bit easier, is I'm going to open up this guy's blueprint as well. And I'll add in a tick event where I just simply get the ability system component for this guy, which have I even gotten him any attributes at all? I don't think I have. So we'll give him the starting attributes for the basic one, and then the default data table. Did I even populate this with any information? Seems like I did. That's very good. And we'll just get his health value every tick and just print that out, just to show you that we're actually damaging him. So we'll print string and say return value, print that out. And then the final step is to add in the gameplay effect that we made, which deals damage. It's very important, obviously. And now that we have all that, we should be able to deal some damage to him. And you see he goes from 100 to 80, and then when we do it again, he goes to 60. And we effectively have a combat system now. It kind of sucks because our attack is really, really clunky, and it's kind of hard to hit, but the basics of a combat system are in here now. There's one little issue that I still want to talk about, aside from the fact that the targeting for the attack really, really sucks, and that is that I am now dealing a set amount of damage. I'm always dealing 20 damage, and if I want to deal any other amount of damage, I need to make a specific gameplay effect for that amount of damage. And there's a couple of ways around this. The way we could do this is in our gameplay ability, we could use the level for the effect that we have, and we could make a custom calculation class that takes that level in and kind of just uses that level as a damage to apply. And that kind of works fantastically fine, but I don't want to dive into making custom calculation classes yet, because that's something that we're going to get into a little bit later. So for now, what I actually want to do, go to our deal damage. Instead of setting this to a scalable float, what we're going to do this is we're going to set this by color. And there we get some other drop-down menus, and we can say the data tag. Let's also call this event.damage. It's maybe not quite an event. You could make a separate tag for this, something like calculation.damage or whatever. We're going to stick with event.damage for now, just to keep it basic. And we're not going to apply a gameplay effect to targets by class, which is what we've been doing so far. What we'll do instead is we will apply a effect spec to the target instead. And that doesn't give us a drop-down menu like this, but it gives us a spec handle. And we can make a spec from scratch, more or less. So what we do is we can make a outgoing gameplay effect spec, and there we can once again choose the gameplay effect that we want to make. So in this case it's going to be deal damage. But now that we have this spec, we have a reference to that gameplay effect. We can actually do stuff with it. We can assign set by color magnitude, or we can assign tag set by color magnitude. We're going to be using the second one there, which is assign tag set color by magnitude. And here we can say whatever tag we put in there at first, so that will be event.damage. And then we can put in our magnitude. So what this will be doing is, because this event.damage matches with our gameplay effect for dealing damage, which is looking out for a event.damage, it's going to use whatever we put into this magnitude here as the value for its calculation. So instead of just applying gameplay effect to target like this, we will want to do something very similar. So the top pin here will be the actor info gameplay ability system component. And then the bottom pin will be our target gameplay ability system component. But before we actually execute that, we will set the value in this gameplay effect here. And then that is the spec that we will be executing. And this magnitude we can simply promote to a variable and call this damage. And to make things a little bit easier on us, this needs to be a negative number. So what we'll do is we'll get damage and we'll simply negate that float. That just turns it into a negative number, and we'll be using that instead. So now we can just simply pass in whatever number we want on a per attack basis, and we'll be dealing different amounts damage. So with all that out of the way, we've got our hero attack 1, which we made last time, which is just a chart of the base attack. And if we go into its class defaults, we can see the amount of damage that we want to do. So let's say we want to actually just do 5 damage attack. It doesn't need to be a powerful attack. And do make sure that in the abilities that you're granting to your character, because I made this mistake myself, you don't use the base attack anymore, because the base attack is not going to have a magnitude set for that. You can set up a default magnitude if you want to as a default value of that variable. But it's a good thing to keep that at 0 so you know when you're using that instead. Let's go to hero attack 1, which is the actual attack that we want to be doing. And then also we want to, when we press the button, use hero attack 1 rather than base. So now that we have that, if we go into here, we'll see that that attack only deals 5 damage. And that is how we can set that up. So now we can very easily just copy hero attack 1 into 2 and 3, open those up and say, hey, you do melee attack B, which deals 10 damage. And we can say, hey, the third one here, you do melee attack C, which does 15 damage. In our character blueprint then, we can say the abilities on start that we want to grant will be hero attack 1, hero attack 2 and hero attack 3, and it will grant all 3 of those. Let's get rid of left shift for now, because what we're going to be doing here instead is we're going to be replacing the left mouse button, which is previously set up for us by the Paragon character itself. And instead of just playing the animation montage, what we'll do is we will try activate ability by class. So we can say, in this case, we want to try activate ability for hero attack 1 and 2 and 3. And I think at this point, you get what we're going for. You probably want to move these set counters to being after the actual ability activation. So for demonstration purposes, let's just like set this to 0 for right now, so that it doesn't move forward at all, because that really doesn't work as well as I would have thought without any extra stuff, which we'll do in like a separate bonus video or something. And now we'll be able to more easily like spam click as well, and we have like a pretty decent feeling combat system, which also takes in like mana. We could of course, instead of making that mana, we could make that stamina and make it regenerate with a infinite gameplay effect that just regenerates like 5 mana every second or something like that, or stamina, whatever you want to call it. And suddenly we start having a pretty Souls-like experience already. And we have the basic setup for what a gameplay ability can do. So next time, let's take a bit more of a closer look at how to bind these two inputs instead. Because right now what we're doing, it works fine, but we can do so much more fun stuff with like activating a ability on a certain input and then waiting for that input to be released, like a charge up attack for instance, and then only when we release that button actually like doing the attack itself. And depending on how long that took, the attack can be more powerful and take up more of your mana. Whatever you want to do with that can be really cool stuff. So next time we'll get into that. We now have attacks in our game, kind of. Only the first one works because the other ones don't have any hitbox triggers. But last time I teased you a little bit because we talked about the give ability and the input ID to go with that. And that's what we're going to be talking about here today, because this input ID system is actually very interesting. So what we're going to do is we're going to map the input IDs simply to the array index of our for each loop. If you haven't been keeping up, I'll go quickly over this. We have an array here which grants a number of abilities on begin play, and it simply just gives each of the abilities here to there at level 0, and now the input ID for those will be equal to the array index. So for attack 1 that will be 0, attack 2 will be 1, attack 3 will be 2, etc, etc, etc. How can we use these, though, is the question. And for that, we're not going to actually be working on the attacks today. Today I'm going to make something that can actually make use of this input system in an interesting way. And what we're going to do about that is we're going to make a jump that we can charge up. So we're going to hold down the button to jump longer, which is actually remarkably easy to do with this. So First and foremost, let's just add a input there for like left control or something like that, because I already have a jump on spacebar. I'm not entirely sure where in the code that exists, so we're just going to do it like this. And when we press that, what we're going to do is we're going to use the ability system component, and we're going to press input ID. And this will ask us for an input ID. And you can pretty much see what's going to happen here. When we press any input ID, it's going to try to trigger a ability with that input ID. So if I, for instance, say input ID 0, when we press left control, I want to trigger that. That will then trigger the corresponding attack. So we'll start up the game here, and at left control, it's going to execute the ability corresponding to that input ID. If I set this to input ID 1 instead, you'll be able to see it will do the attack corresponding to input ID 1. And let's do this animation first, and now you can see it does the other attack instead. Now, a fun thing that you can do to make use of this stuff is we can make a blueprint enumeration, and let's just call this hero abilities, because what an enumeration is effectively is just a name that is mapped to a value for an integer. So let's add an enumerator here, and we'll call this attack 1, and we'll add a couple more. So we'll add attack 2, and we'll add attack 3, and then the next one we'll just call this jump, and make a variable called ability to do or something like that, and we'll make that of type hero abilities. And this is the fun part, because this is an enumeration, which again, enumerations are just integers with extra steps. We can change this to an integer or integer 64. And now we have this drop down menu here, which we can say ability to do is attack 1. And if we do that, I'll just do it in a preview window like this, we will do attack 1. We can very easily just change this to attack 2. And now if we run this, we will be doing attack 2. Mark my words, this will be attack 2. Because again, these enumerations are just storing integer values. So the first one in your list will be value 0, this will be value 1, value 2, and value 3. So that's a little bit of an easier way to keep track of like all these index numbers and all these values than having to like note them down in a notepad or something. Just make an enumerator which corresponds to all the abilities that your character can do in the order that you assign to them, or at least with the input ID matching. All that said, let's start making that charge up jump that I mentioned. So what we're going to do here is we'll just make a new blueprint class, which will be a gameplay ability, and we'll call this gameplay ability charge jump. Opening it up in the event graph, we'll activate ability, and we can also like use some mana. We can use the commit ability just like we did with the attack. We're not going to do that right now. For this one, we're simply just immediately going to wait input release. We can test whether or not it was already released by the time we get to this or not. But there we can just say on released, we want to apply root motion jump force. And the distance we can set to, for instance, 250. And then the height will be influenced by the amount of time that we held down the button. And this is the very, very interesting stuff, right? So let's say that our jump lasts for like 1.5 seconds. We'll finish on landed, and all of this doesn't really matter too much for me right now. And here is where we get to the interesting stuff. This wait input release automatically just looks for the same input ID that this ability is activated by. So you don't even need to specify anything to do with that. And if there's anything we want to do in the code immediately, before we even release that, of course, we can just use the stop pin. And we also get a reference to this async task if there's anything we want to do with that as well. That is a possibility. So for now, let's say the time held. Let's take the minimum between that and like 10 seconds, and we'll multiply that outcome by 100. So The maximum amount that we can jump will be set at 1000, but if we let go before 10 seconds, we won't be jumping as high. And that is the basic idea here. So again, this is a very basic setup for a charge up jump, but this same principle can be used very much for also charging up an attack. If you have like a fireball attack, something like that, a magic spell, maybe its speed at which it travels will be impacted by how long it has been charged up. Obviously, the damage of an attack can be influenced by how long you held down your charge up button, and so on and so forth. This is a very easy and quick way to implement something that can otherwise be quite tricky to deal with. And then on landed, of course, we want to end the ability. So let's go back into our player here, and we add in that new ability. That's gameplay charge jump. And we'll set our ability to do to our jump. What is important to understand, going back into our character's blueprint, is that we also have to release this through a similar node as we press it. So we say press this input ID on left control pressed. We can also then say release input ID, and we'll use the same ability there. This is a little messy looking at the moment. Let me fix this up real quick. And the wonderful thing about this is because it is not directly bound to a button, which might be intuitive in the first place. The great thing about this though is that we can still very easily say, okay, so we press the input ID, which is kind of like a virtual button press that we're doing when we use the left control. But then it keeps charging up and we can let go of left control, and then pressing in another button can be the release of the virtual key. So this is more like activating and deactivating a state for the key that we're looking at. It's not as much necessarily actually pressing in and letting go of a certain key. But now that we have this hooked up and we go back into the gameplay, we can let this intro animation play out for a little bit. And what we can do is we can press this in and we'll see it print out hello as a test. And then when we let go, it jumps. And it will jump depending on how long I've had it held down. So I'm holding it down for quite a bit now, and it will jump much higher. And if I only hold it down for a mere moment, it doesn't jump as high. Of course, we probably also want to impact the duration of our jump with that, and frankly probably maybe also the distance. I put these strings in here for just testing purposes. So let's say the duration is going to be a multiplication of 0.15 times the minimum between 10 or the time held. So that way it should feel a little bit more natural when we have a short little hop that just hops us forward, and a longer jump that will last longer. There might be a little messing about with the exact values to get this right, obviously, but this is just a short hop, which is way too much. That's not okay. And if we hold this longer, that should end up with a... So maybe set this to something like 35. And as a matter of fact, we probably want to also give it a minimum value. So after we take the lowest value between the time held and the minimum, then we're going to use that and take the maximum value between that and just 1. That way our value will always be at least 1, and we don't get any weird stuff. So we can just tap it and that will do this. And if we hold it down for less than 1 second, it will do more or less the same thing. It's always jumping in that one direction, which we're going to ignore for now. But if we hold this down longer, again, we're going to jump a fair bit higher. And now the jumps seem somewhat more reasonable as far as like the timing of them goes. So that is one of the many things that we can do with having these virtual input IDs that we can use. Just to show you a little bit more, the other things that we can do with input, if we go up to the tasks, is we can wait for a input to be confirmed, and we can wait for a input to be, well, pressed as well, actually. So what we can do is, this is all referring to the input for this specific ability. So when we press this one time, we start the ability. But then when we press it again is when we actually do the jump. So that's another way that we can do this. And this time we don't have to hold it down. So I can press this once and then I can wait a couple of seconds. And then when I press it again, it actually executes the ability. Because right now the ability is active, but it's just stuck on waiting for me to press it again, at which point it will execute the actual ability. And in much the same way, we have these confirm inputs and cancel inputs as well, which you can use to wait for as well, which is just a slightly different way of looking for these inputs. Input confirm will only work if the input has actually been pressed. So you press the input and then the input has been pressed. You can do whatever you want with it. The ability is started. But then maybe you only confirm the input at some other point and you're waiting for that confirmation, which if you, for instance, have a ability that pops up a little menu, for instance, something like that, you can set the value of whatever should happen in that menu. And then when you press in that menu button, it confirms the input and it moves on. Same thing here with input cancel. Maybe there's a way that you don't want to like release the input, but you want to cancel it instead. That's an option that you have that is distinctly separate from just releasing that button. And that is the basics of the input ID input system that you can use with the gameplay ability system. So it's a very powerful thing. It is a little bit iffy to wrap your head around because you're talking about buttons and inputs, and you might think, I've probably used them interchangeably in this video, and if so, I'm very sorry, because these inputs are not necessarily buttons. It's very easy to think of them that way, and in general, you will probably hook them up like this, where the input ID pressed will be when a button is pressed, and released when the button is released, but it doesn't necessarily have to be that way. We're slowly getting to the point where we are wrapping up the gameplay ability system. At this point, you can practically do whatever you want with it, and there's only a couple of things left to cover. So one of those things is going to be gameplay cues, and we're going to be talking about that today. So what is a gameplay cue? We've talked about gameplay abilities, gameplay effects, gameplay attributes, and a bunch more things. So now a gameplay cue. A gameplay cue is something that you can attach to a gameplay effect. So let's take a look at a new effect that we're going to be making here real quick. And we'll just make that in a blueprint class, and we'll make a new gameplay effect. And we'll call this gameplay effect Regen. And very simply, we're going to set this duration policy to has duration, and the duration magnitude is going to be 5 seconds. Then in the modifiers, we'll say our basic attribute.health. We're going to add to that 5 HP. Then here in the period is how we define how often we add that 5 HP over this duration. So let's say we want to add this every 10th of a second. So 10 times a second for 5 seconds, we're going to be adding 5 HP. Maybe adding 1 HP, because 5 HP seems like quite a lot. So that's 10 HP a second for 5 seconds, total of 50 HP regained through this ability. Now, we've done all of this before, right? This is nothing new. But what we want to do is during the activation of this, we want to have a regen particle system around us to visually show that we're regenerating health. So what we can do, all the way down here in display, we can add a gameplay cue. And there we can open that up. We can use a magnitude attribute. We can set a minimum and a maximum level. We're not going to really care about any of that right now. That's for you to discover on your own. We're just going over the basic idea. And we can set a gameplay cue tag. So we can say a gameplay cue dot healing is a tag that we can make. And now it will look for a gameplay cue that is tagged with this tag and apply it. So we're not even pointing it directly at a asset or at a class or at a whatever. We're just saying, hey, take something with this tag and apply it as a gameplay cue, as a visual indication. This can be either really, really nice, or this can annoy the ever-living hell out of you. Personally, I don't like this. I would much rather just have a pointer to a specific asset that it applies. That's sadly just not how this works. You do need to do this through tags. So let's make that gameplay queue, shall we? We can just make a gameplay queue through a blueprint class, and we can say gameplay queue. And now we have two different options. We have gameplay queue notify static, and we have gameplay queue notify actor. So the difference being is that the notify static, if you hover over it, the tooltip will tell you, this is what you kind of use for things like hit particles. Things that just are a single burst of particles that spawns in and then is dealt with. The gameplay queue notify actor is a actor that spawns in, that is parented to whatever actor the gameplay effect is taking place on. And this can hold a continuous particle system that continuously spawns in particles for as long as it's needed. I will real quickly show you a gameplay notify static and just walk you through it because these are a lot simpler, and then we'll go through the gameplay notify actor, which is going to be the one that we're going to be using for our healing particles. So let's make this static one and call this gameplay queue, let's call this jump particles. In here we can set our gameplay queue tag. We already have made a healing one, but let's actually also just make a jumping one. So we can add that new tag, jump, and now that's set to gameplay queue.jump. Now over on the left hand side here we have 5 overridable functions, that being handle gameplay queue, on activate, on execute, on remove, and while active. You can use either on active or on execute. The difference is this is called when a gameplay queue with a duration is first activated, and this is when it is just executing for the first time in general. So we're going to use on execute here, and we'll just spawn Niagara system at location is what we're going to be doing for this one. And let's see, do we have any systems in here? We of course don't, so we'll have to make one real quick. I just made a system from the confetti burst. Then we're going to hook up this into the parent nodes actually as well. That's quite important. And then my target is going to be the target that the gameplay effect is being applied on. So we'll just get actor location for that one, and we'll spawn particle at that location. And this is as simple as it is for just spawning in things like, again, this is mostly useful for stuff like hit particles and that kind of stuff. So I made a quick gameplay effect here for jumping. We're not actually going to modify any of the attributes with this gameplay effect. You could, of course, you could say, hey, if we jump, we probably want to, I don't know, take some of our stamina away or something like that, some of our mana. But for the sake of just showing you how this works, I'm going to skip over all that, and we're just simply going to go into display, gameplay queues, and we want to get a gameplay queue with the tag gameplay queue.jump to spawn in whenever this gameplay effect is applied. Then we'll go into our gameplay ability for charge jumping, which we made in the last video, I do believe. And then after we start applying the root motion jump force, we'll apply gameplay effect to owner, just to itself, and we'll apply the gameplay effect for jumping. And now if we go back through and we press Ctrl once, that starts the charge up for our jump. And if we press it again, we jump, and you can see it spawns in those particles that we set to that gameplay queue, which is very, very neat. So this is the way you can do things like, well, jump particles also can be a good thing, especially for things like charge jumps and stuff like that. But what we wanted to do is we wanted to make something that shows that we are regenerating. So let's do that next. So for shits and giggles, I just made a quick little green fountain that we're going to be spawning in and activating and deactivating whenever this becomes relevant. Now, next up, we're going to make that gameplay queue notify actor, and we'll call this gameplay queue actor healing regen. And here we will see we have 24 overridable functions, which is a lot of things here to do with just actors, because what we're doing here is we're spawning in an actor. So we have the usual actor stuff with begin, curse, over, destroyed, end play, begin play, all that kind of stuff. And then we also have the handle gameplay queue on active, on execute, on remove, and while active. Very similar to the last one. Now with this you can do a lot more than just spawning in a particle system and doing whatever you want. You can do anything you want that you could do to an actor here. For us that is simply going to be a Niagara particle system component still, but you could add meshes and animations and whatever you want if you really wanted to. So let's add in the healing particle system here. You can see it spawns in. And then in the override what we're going to do is we're going to override the onActive, which is the function that runs when this activates. And then we're also going to override onRemove, which is the function that runs when this gets removed from the specific character that the gameplay effect is applied to. So the gameplay effect itself worries about applying and removing itself from the actor that we're applying it to, and these two functions just say, hey, when I am activated in the first place, I will do something, and then when the gameplay effect that I am linked to is removed from said actor, I will do something else. So the easiest way, of course, to do that is just to drag in our Niagara system here and say, hey, we want to activate you when we get added, and when you get removed on remove, we want to deactivate. Now, if we go up here to selecting the actor as a whole, we have some cleanup stuff to do. We can automatically destroy this actor when we remove the gameplay effect. So you'll probably want to do this in most cases. We can, however, set a destroy delay, because if we're doing something with particles, we can say, hey, we want to deactivate our particle system, but our particles live for like 2 or 3 seconds. So we want to wait that long before we actually destroy this actor. So let's wait for 3 seconds. I think that should be pretty good here. Then we're going to make sure in the gameplay queue section here to add in the gameplay queue tag that we gave the gameplay effect to. And in this case, we also want to automatically attach this thing to the owner. This just attaches the transform for the actor that we spawn in to the transform for the actor that we're applying the gameplay effect to. That way they will move with it. And that is the basic setup of how you can make a gameplay queue for a burst or a gameplay queue for a continuous thing. So let's make a quick gameplay ability here for gameplay ability healing regen. And all this is going to do is it's going to, we probably should commit ability and we should make a gameplay effect that takes down like 50 of our mana in order to start this regen. We're going to skip over all that for the time being. We've gone over that in previous videos. So we'll just apply gameplay effect to owner, and the gameplay effect we're going to be applying will be our regen. It's just going to be that simple for now. Then coming back into our player here, I'm going to add to the array that I've made for the abilities that I grant on begin play. I'm going to add in the ability for healing regen. And we'll just use the left control thing that I've been using for testing purposes. When we press that, we'll try to activate a gameplay ability by class. And we'll try to activate the healing regen. And in the gameplay ability itself, we do want to also end the ability after granting the gameplay effect. And realistically, we probably also want to like play an animation here. And with all that, we probably should make sure that we can't cast this while we're already being regened to begin with. So we want to go into our gameplay effect regen here, going down into our tags. And I think in our granted tags, we want to add in a new status effect, which will just be called, let's call it specifically regen. So that should add the status.regen when we apply this, and I do believe that when we end this effect, it will also automatically take this away. Then in our gameplay ability for the regen applying, what we're going to do is in our class defaults, we want to check our activation blocked tags, and we want to block the activation of this ability if we have the status.regen already active. And of course, we want to end the ability on complete for the animation, now that we have a animation. So let's test that out, shall we? We can start up the game here, that's all fine and good, and then we can press the left control and we start the healing ability, and the particle system is parented to it. It'll go for 5 seconds and then disappear, and then we can do it again. But we can't do it as long as we're healing. So everything that we needed to work for our healing regen spell now straight up just works. And just to show you, I will also print out on every frame now the value of my health, so you can see it's actually going up as well. So it's 100, and you will see if I start doing this, it starts going up to 150 in theory. 151, there's one more HP that we get out of it, and then we get this, and this should now be going up to 202. Of course, you do need to put in some amount of code that prevents you from going through the max value that you have. And that's where these modifiers and gameplay effects tend to start falling a little bit short, because these are very good at just adding and removing things in a very non-intelligent way. But as soon as you start getting into some more complex calculations where you need to like clamp stuff, or you need to take in multiple different attributes to calculate one different output, these modifiers don't really cut it anymore. So next time we're going to go into the executions, where we can make our own custom calculation classes that do exactly that, taking in more complex calculation to make stuff like that happen. Let's talk about some more complex calculations for your gameplay attributes, because so far, if we for instance go into my gameplay effect for a regen, we've been using the simple instant and has duration and infinite ones with just simple modifiers where we say, hey, add a certain float. We've even used the set by color, and I've covered the attribute based ones to simply modify an attribute very directly. But sometimes that's not quite enough, as we saw in the last video where we wanted to check, hey, increase the health attribute but don't go over the max health attribute, and we can't do that with these simple modifiers as easily. And that is where we go into the custom calculation classes. There's two different types of custom calculation classes. The ones that we use for the modifiers here, for the magnitude of a modifier. And then we also have a execution calculation class. Both of these we're going to talk about in C++. There is a blueprint version of the magnitude one, but I don't think it actually works. It seems to be lacking a few features that are pretty pivotal to actually having it work. It seems to be bugged, and it has been bugged for about a year. So I don't think they're going to be fixing this anytime soon. So both of these are going to be C++ related. We're going to take them one at a time though, starting with the magnitude calculation first, because it's the easier of the two. Most of the time you're going to be using these. I'm going to go real quick over when to use one and when to use the other. So strap in for a little bit of theory blasting. By default, you should be looking at using the calculation for the modifiers. And that is because, number one, they're easier to set up, and number two, they can be predicted over the network. So if you get into a habit of using these more, if you ever move into using the gameplay ability system in a multiplayer game, these are going to work a lot better. Whereas the execution classes have some trouble with that, from what I understand. Now, what is the limitation though of the modifier calculation? The only real big limitation to it is that it is a modifier to modify one attribute. If you want to do a calculation that needs to influence multiple attributes, I'm going to give you an example here. For instance, in my own game, I have a system where all my enemies have both a defense bar, which is more of like a guard that protects their HP. So as long as they still have some of that defense, all of my attacks only ever do 1 HP of damage. The moment I get rid of the entirety of their defense bar, I can actually start dealing more damage to their HP. So every time I hit them, I need to influence both their defense bar and their HP bar, two different attributes. For that, you use an execution class instead. So that's a real quick overview of the difference between the two of them. Let's get started with making one. If we come over here into the C++ classes, you can see I've already made a public folder here, and I made a class, but we're going to go over making one real quick. If we make a new C++ class, and we go into all classes, and we just simply look for calculation, we get the options for gameplay effect calculation, which is the more complex one, and then gameplay modifier magnitude calculation, which is the one we're going to be talking about today. It does say here, class used to perform custom gameplay modifier calculations, either via blueprint or native code. This is a lie. Just straight up not true from what I can tell. We're going to be using it though in C++. But as I said, I already made a C++ class because I was testing this before. So let's open up that C++ class. When you open this up, there's going to be nothing in here. And we're going to add a constructor and a specific function, which I have on my clipboard right now. So I'm just going to paste them in. The constructor is always going to be the name of your class as a function. And then we're also going to be adding the virtual void calculate base magnitude underscore implementation with the parameter const f gameplay effect spec reference called spec, which will be a const override function. Then in the header file, we also need to define what attributes we're going to be capturing. So we want to add f gameplay effects attribute capture definition, and we'll call that health definition. Indeed, GitHub Copilot's being very clever, and let's see if it has, it doesn't know what I want, because we also want our max health definition. So let's change this around real quick. Now we can go into the CPP file, and I already have set up the constructor and the calculate base magnitude implementation, which you can just do in Visual Studio by right-clicking and create definition. So that should be fine. In our constructor, we're going to use our health definition, and we're going to attribute to capture, and we'll set that to be equal to our attribute set that we have made. So that's actually, I'll zoom in a little bit more so you guys can actually see a little bit better. We call it a base attribute set. So we probably need to include that to begin with. Okay, so now that we have this included with the basic attribute set, we can, and Copilot already is suggesting it, say our U basic attribute set, and then we can get our health attribute from that. So now this definition knows what attribute it should be looking at, but it still doesn't know where it should get the attribute from. So we get our health definition attribute source, and that will be equal to E gameplay effects attribute capture source, and that can be either set to the target or the source. The source being the thing that is applying the gameplay effect, the target being the thing getting it applied to it. So in this case, that will be the target. And then we can set up whether or not it should be a snapshot. Snapshotting simply means that it takes the value at the start of this whole calculation and keeps that as the value that it's going to be using. So if you're working with like a gameplay effect that lasts for 10 seconds or even like longer to infinitely, and there's a chance of the value changing mid-calculation or mid-effect, but you don't want the changed value of that attribute, you can set this snapshotting to being true. If you do want to always have the latest up-to-date information on the value of a attribute, then you set this to false. And most of the time I do find that you want to set this to false. And then we kind of just do the same thing with the max health attributes, which Copilot is very, very nicely doing for me here. Then in the relevant attributes to capture, which is an array that is pre-made for you that you can use, you can add these two definitions that we have made here. So now we have access to that very easily, and we have them set up, telling them to get a specific attribute from our set, telling them where to get the attribute from, and whether or not it should be snapshotted. Now that all of that is set, we can add it to that array. And with that, we can move on to the actual calculation here in the next function down the list. Here we need to set up a few things first as well. So that will be our const f gameplay tag container. So that will be f gameplay tag container, pointer, source tags, and it will be equal to our spec.capture source tags dot get aggregated tags. So that's this whole list that we've got over here. And then we'll do the same thing with the target tags. Next up, we need to set up our f aggregator evaluate parameters, which is this one here, and we'll call that evaluation parameters just to keep things simple. And in those evaluation parameters, we set our source tags to the source tags that we just captured and the target tags to the target tags that we just captured. We need to have these tags because some of the functions that we're going to be using in a moment require the use of these tags. Now, we make a float for our health value, and let's also make a float real quick for our max health. because we're going to be needing both of those. Then what we will do is we need to get the value from that captured attribute that we made before. So we can get captured attribute magnitude, and that will take in our definition that we've made, the spec that we get as a parameter on this function, the evaluation parameters that we have made, which requires the source tags and the target tags, and then our float value that value is then going to get put into. So from here on out, we can do all of our calculations with this float that we've called health, instead of having to worry about getting the attribute every single time. All of this is just set up to get that attribute, put it into a float so that we can actually do math with it. And we'll do the same thing here for the maximum health. So now that we have all of that set up, we can actually start doing our programming logic, which is all relatively simple. Our default return here is going to be just 1, so 1.0f. But if we have a health that would increase past our maximum health, we want to do a little bit of extra math. We're going to return fmath clamp between 0 and 1, that is true, and we're just going to say max health minus health. So this will take our max health, let's say that's 100, and our health, let's say that is 85, which will be 15 if you subtract those from each other, and then we'll clamp it to between 0 and 1, so it's going to be 1. This is the easiest way to do this. It's honestly a more elegant way than what I had before anyway. All of this code, like this bit of code, you can literally just copy paste in every single calculation. This doesn't change between calculations. These only change depending on the attributes that you want to capture, and you do need to define that. And the same thing goes for these. This is all very simple boilerplate setup once you actually understand what all of these lines of code do. They're not that complicated. Of course, if you have multiple different attributes, everything beneath this can be a lot more complicated than the very simple setup that we have right here. You can do a lot of awesome stuff with this. And don't forget all your semicolons. I almost compiled with an error. So now that we have that set up, we can change in our gameplay effect regen from using a scalable float instead to a custom calculation class, which now will have our calc regen class in here. And we can still pre-multiply additive and post-multiply additive values, and we can use a coefficient to make it scale up to be more effective, all that kind of stuff. We're not going to worry about any of that stuff right now. With all that done, let's set our base health attribute to 80, so we spawn with 80 health, and our maximum health will be set to 120. A quick disclaimer, if you have any issues with getting errors here in your output log saying that it can't capture certain attributes, maybe you should not use live coding, just close the engine entirely and rebuild from your source in Visual Studio. That can help that issue. So you can see we have 80 HP now, and I can enable my regen effects and it will go up to 120 and it will stop there. And even if I do the regen effects again, it doesn't go over 120 because that is what we programmed in. And that's the basic idea behind these more complex calculations that you can do for your modifier magnitudes. Now, again, this is the version of custom calculations that you should most of the time be using, but if there's anything more complex that you do need to do which influences multiple attributes, we will be going into that next time with custom execution calculations, which are a little bit more complex. Now that you have a good grasp on these custom modifier calculations, it should be an easy step into all of that. So I'll see you back with that video next time. We've been doing a little bit of custom calculation for our attributes, and today we're going to do a little bit more of that. So last time, if you're following along with the series, we made a custom calculation class for a modifier magnitude calculation. And for the most part, that works for about 95% of calculations you're ever going to have to do. Today, however, we're going to go into the calculation executions, and I will warn you that with the basic setup that we have in our example game that we're working with here, I don't really have enough game design and enough different attributes to really show you an example of when this would be useful. I could put my own game up here And as I explained about in the last video, I have this system here where the enemies have two bars. The blue bar is defense, the top bar, the green one, is HP. And as long as they have defense, I will always do 1 HP damage, but the moment they run out of defense, I will start properly doing health damage. And that is something I do through a custom calculation execution, because I need to both influence their defense bar, as you can see it regenerates after a certain amount of time, and their HP bar. And that's all based on my attack value as well, based on my weapons attack value on top of that, and based on the enemy's defense value as well. So there's a lot of different attributes that are getting added together, and then it influences two attributes at the end. So that is the reason that I'm using a execution here. For our example, we don't have anything that complicated in this project. So what we're going to do is we're going to increase the health during the regen and decrease the mana at the same time. Usually the way you would do this is to just add a second modifier. Just doing two modifiers, one to increase the health and one to decrease the mana. That would be the way you do that. But as I'm just doing this to show you as an example of how to set this up, we're going to do it through a custom calculation here. So I just removed the modifier that we have been using this entire time, and we're going to be making a custom execution calculation. So let's go into our C++ classes, and we'll make a new class. We'll go into all classes and use the gameplay effects execution calculation. And we'll call this calculation execution regen. Now, there's going to be a lot of boilerplate code for this. If you watched the last video and you thought there was a lot of setup for that, you're in for a bad time. So a lot of this is, if I remember it, if I don't, please shout at me in the comments and I will put it in there. A lot of these like copy paste type of things, and maybe even some of the example stuff, I'm going to put in probably like a pinned comment or down below in the description for you to copy and paste, because a lot of this is just stuff that you can throw into your project and just kind of not think about. But what we will need is we will need a constructor first and foremost. So we'll just add the name of our class as a function, and then we will need a function with a very long name, that being a virtual void execute implementation with parameters for const f gameplay effects custom execution parameters, reference execution parameters, and another one called f gameplay custom execution output, reference out execution output, and it's a const override again. So this is one of those things that's like very long, you don't want to have to type it, so just copy paste it, it's fine. Let's make a definition for both of these. And now we get into the fun stuff, because where the modifier calculation that we did before had some stuff pre-set up very easily for us to capture attributes, we're going to need to do a fair bit of that ourselves. And this is something you can't really copy paste over that well, because it heavily depends on what attributes you need for this calculation. So let's start off by making ourselves a struct called damage capture. In here, we're going to declare the attributes that we need. So the way we do that is with a macro called declare attributes capture def for capture definition, and then you put in the attribute that you want to capture. So for us, we want to have health, we want to have max health, we want to have mana, and we don't really need max mana actually, because that's not really gonna be that relevant. You can hover over these to see what they do under the hood. Don't really worry about it, just type out this whole declare attribute blah blah blah. Then this struct is going to need a constructor of its own, so let's make a damage capture constructor. And what it's saying here is actually correct. So let's walk through this. You can thank GitHub Copilot for making this a lot easier on me. So we have captured these attributes now, but now we need to define them. So the way we do that is with define attribute capture definition. And there you're going to pass in the attribute set that they are from, the attribute that we're working with, which is in this case health, whether or not it is the target or the source that we're looking at. In this case, we're applying it to ourselves, so it's the exact same thing, but because we're doing a regen spell, if we want to put it on something else, we want to concern ourselves only with the target. But for the mana, we're actually going to be concerning ourselves with the source. And I do believe that these last bools are there for snapshotting. If you don't know what snapshotting is, go watch my last video. I'm not going to explain that again here. We do need to include the basic attribute set though, because we're now using stuff from it. So let's include. And at the end of the struct, you also need to put a semicolon so that it understands that this entire thing is a struct. And now that arrow up there disappears as well. Next, we need to get a getter for this struct. So we'll make a static damage capture reference, and we'll just call that get damage capture. And all that we'll do is make a static damage capture for damage capture, and then it will return that as a value. It's just simple, but we need a way to get all of this capture attribute stuff that we've made up there. Now, in the constructor for this calculation class is where we're going to start doing some fun stuff, because we need to have the relevant attributes to capture, and we need to add our damage capture and then all of the things that we have made definitions of. So Copilot, again, is just providing these for me. So what we do is relevant attributes to capture dot add, and then we use our get damage capture, which we have up here, that makes is a instance of this struct over here. And from there we can get our health definition, which is the thing that we made down here in this. So this is where we capture them. This is where we make the definitions. This function makes a static instance of it, and that we can access through this way. So you simply repeat this line of code and swap out your different definitions for every attribute that you need. I only need 3 of them at the moment, but you can make as many as you need. And the same thing goes for everything up here. If you need another attribute added, you just add it with a line like this and a line like that, and that's as easy as it is to add more attributes. Now we get into the execution implementation, which again needs a little bit of a boilerplate. So let's get into that. The first thing we want is a U ability system component pointer, and we'll call that one target ability system component. That one we will set equal to execution params dot get target ability system components. So exactly what Copilot is giving me. Then we'll make a actor pointer, and we'll call that target actor, which will be the target ability system component, get avatar actor, or null pointer. And then we'll do the same thing for the source. So source ability system component and the source actor. But that's not the end of it though, because we also need to add in our const f gameplay effect spec reference, which we will get from execution params get owning spec, which is exactly that line. Then we also need a gameplay tag container for the source tags and for the target tags. So let's make a const gameplay tag container for the source tags, which we can get from spec.capture source tags.get aggregated tags. And then we'll do the same thing for the target tags as well. Again, this is just boilerplate code that needs to happen in every single calculation that you do. And then the last bit of boilerplate that we need is the f aggregator evaluation parameters. To that we will add those source tags and those target tags with evaluation parameters dot source tags equals the source tags that we just made and the target tags all the same. So once again, specifically like this bit of code, including probably the name of the entire function, I will put in the comments and or the description down below for you to just copy and paste, because this is tedious, and for the most part it's good to roughly understand what is going on here. If you don't quite understand everything that is going on here, it's going to make troubleshooting things, if they go wrong, a little bit harder. But don't beat yourself up too much over it, because you don't really interact with any of this code. This is just setting up stuff So the engine has the information that it needs to do its thing. After this is where we start doing our own code. So we make a float for our health, and then in our execution parameter, we can attempt calculate capture attribute magnitude, and then we can get the damage capture again, our health definition, in this case, the evaluation parameters, and then our health float. So what this is going to do is it's going to try to take the health attribute and put it into this float. So going forward, we can just use this float in our calculations, and we don't need to worry about using the attribute anymore. It's now just simply a number. And we'll do the same thing with our max health and with our mana. And here we can pretty much use the line that I used in the last video here, which is just we're going to set our amount of health that we can increase to just like this over here. So we'll make a float health to add. And this won't be the return value like it is with a magnitude calculation, because we are not doing anything for a magnitude. We're actually executing stuff. So we need to specifically add code to set the new value here. So in between here, you can do all of your fancy calculations and take in all of the attributes that you want and calculate them and multiply them and divide them and exponent them and whatever you want to do with them. Then when we actually get ready to do everything and apply everything to those attributes again, because remember, right now we're just working with numbers, with floats. We're not working directly on the attributes. So we need to set those attributes back to the new value. We'll use the out execution output, which is going to be another one of these very long strings of text. So bear with me here. We're going to go through this one thing at a time. So we'll use the add output modifier, and this will just work just the same way that using a modifier set to a addition operation does, but through code specifically. So we have the gameplay modifier evaluated data, in which we use the get damage capture dot our attribute property. So that's something that we don't define for ourselves, but through defining them with these macros, we get access to this health property. It just makes that for us. It's a little bit confusing using these macros, but I'm going to be real with you. It's going to be more confusing if we dive into what those macros actually do and how they work, because they're a mess. Then we have the eGameplay modifier operation, which can be additive in our case, but we can also make this division or max, multiplying or overriding, just like we are used to. And then we put in the float for the magnitude of that operation, so the amount of health that we're going to be adding. And then in more or less the same way, we can use that same line of code here to say our mana property instead is going to be added to, but we'll add the negative health to add here. This still doesn't have clamping, so we can go into negative mana at this point. So what we really want to do is we want to also check, hey, do we still have mana? If not, we want to set both of those values to 0 or whatever, something like that. This isn't a course about basic programming. This isn't a course about like basic mathematical logic. So I'm not going to waste your time with all of that mumbo jumbo, which is kind of tangential to the topic that we're talking about here, and that is actually setting up the gameplay ability system stuff. I will also show you a quick alternative way to do this. So instead of using this like health to add that we're doing here, I'm going to remove that. What you can also do is, if you want to change something on either the source or the target, you can use that ability system component reference that we've made before, that pointer that's somewhere up here, one of these two. You can use those to, let's say in our case, the target ability system component. We can also use the apply mod to attribute. You can use the unsafe version if you're feeling very daring that particular day. And there we can do it with this way. We can get the attribute set and then a get attribute, whatever. In this case, it would be mana, or actually health. We want to influence the health. So we want to say get health attributes. And then we can use the eGameplay mod operator for additive and then health to add. This is another way to do this. So if you hover over it, you will see the difference. It applies a in-place mod to a given attribute. This is correctly updated to the attributes aggregator, updates the attribute set properly, and invokes on-dirty callbacks. This does not invoke pre and post gameplay effects execute calls on the attribute set. This does no tag checking, application requirements, immunity, etc. No gameplay effect spec is created or is applied. This should only be used in cases where applying a real gameplay spec is too slow or not possible. So this is not a function that they really want you to use. This is not the way you really should be doing it. You shouldn't be getting used to it. But if for any reason this is giving you any trouble, this is an alternative way to do it. In one of my own calculations, I'll take my damaging for the enemy for my own game here. I don't remember exactly the issue that I had, I'm going to be honest with you here. But setting the defense lower on that enemy worked properly, and setting the HP lower on that worked properly. But when I attack, I also increase my own mana by the amount of damage that I do, and that just didn't want to work with the usual add output modifier. So I used this apply mod to attribute instead, and then it started to work. So do be aware that this is there as an alternative, but this is not the way you should be doing it. The add output modifier thing is the way that you should be changing your attributes at the end of your calculation. And now with all of that done, we should be able to compile and everything should work as expected. So we can go into our regen here, and in our executions we now should have the calculation execution for regen, and in here we can even put in like calculation modifiers still if we wanted to. So here we have the captured attributes that we have. So we have the health on the target, it shows you all of those, and then we can say, hey, actually the modifier operation for this, we want to do some stuff with specific attributes that we captured, and you can knock yourself out and do real good stuff even beyond what you've programmed in C++ on an individual effect basis, modifying those things. For right now, we're just going to use the calculation for the regen like this. So now if we enable our regen, we should see it again is working, counting up and stopping at our maximum HP of 120. Now, I do want to once again clarify, just to be sure, that the way we did it in the last video with the modifier magnitude calculations is for this specific use case the way you should go about doing it. You shouldn't overcomplicate things and use execution calculations for that. The only reason that I'm doing it here is because we don't really have a game here with like a lot of game design to it with the complexity that requires something like that. The example that I showed from my own code is a much better example of this. So let me walk you through that real quick. Like, this is my own code that I use for damage calculation toward enemies in my game, where I use the attributes for defense, health, damage, and strength. You might think these are the same, but I think damage is inherent to your level and strength is your weapon, or the other way around, one or the other. I get the mana and the max mana, and then in the capture definition here, of course, we do all that. Then we set up this simple function here, which just needs to exist. In the constructor, we go through all of those attributes as well. Then you see all of these code lines of code that I have here are the exact same in my own code. 100%. They don't need to change one single bit. And then we capture all of those attributes into floats. And then I do a little bit of math here to check how much mana I should add, depending on how much damage I'm dealing. Then how much damage am I dealing, taking into account the defense. Then we by default set the HP damage to 1, because that's the minimum it should do. If the damage to deal to the HP is more than 0, we add that, multiply it with strength, whatever, and then we output execution to 2 different things at once, that being the defense damage that we're doing to the defense bar, as you saw at the beginning of the video, and then the leftover damage will go into the HP bar damage. And I'll also add mana to my own character. So I'm influencing 3 different attributes here with 1 calculation class, and this is the kind of stuff that you should be using calculation classes for. Because all of these 3 attribute changes are dependent on each other as well. So that kind of complexity is where this more difficult version of custom calculations comes in. That said, I hope that has been a helpful video for you. It's a bit of a nightmare to get into specifically these calculation classes, but between the previous video and this one, that's pretty much the most mind-boggling thing about a gameplay ability system now covered. So we'll have a little bit of fun with it in the upcoming video or videos, and then we're slowly wrapping up toward the end where you should really just go out and experiment on your own. To end off this introduction course for the gameplay ability system, we're going to lightly touch on letting the AI do some stuff. Because so far we've been working entirely with the player character here, and in theory we could like attack this enemy character and we could give him HP and stuff like that. We're not going to bother too much with any of that. I hope that by now you understand how to do that. But I do want to go over how to use gameplay abilities on enemies. It's not that different from the way you would use it for a player character. There's a couple of things here though that I do want to show off. So let's set this guy up real quick to have a behavior tree. I'm going to go through this real quick because it's not a behavior tree tutorial, obviously. So what we'll do here is we'll make a new AI controller. In the event graph on begin play, we will run behavior tree. We will make a behavior tree asset from the artificial intelligence behavior tree. We'll call that BT enemy. And to go along with that, we'll also make a Blackboard, which we'll call BB enemy as well. We'll set the AI controller class to the AIC class that we just made. So it will now run this behavior tree, to which we'll add a selector, and I'll add a task, simply just move to. And in the Blackboard, I will add a object here, which will be the player. The object type will be not any kind of object, but we'll specifically say that this is an actor, which will set in the behavior tree here. So we can get the Blackboard, set value as object, and the value for that object will just be the get player. So now we have a reference directly to the player. But now there's one more thing that I want to do before we get into like making tasks and decorators and stuff to make this guy work. And that is, we actually want the Blackboard here and the behavior tree to be able to access our gameplay ability system components, because all of the tags that we apply with our abilities, like when a ability says, hey, apply the burning tag whenever something gets hit with this attack and stuff like that, right? We've gone over how those tags work. Those tags don't get added to the actor itself. Those tags get added to the ability system component. So we need a reference specifically to that, because you can check the tags on that component as a decorator on this behavior tree. So we will be making a other object here, which in this case we'll call ABC for ability system component. And here we get into a little bit of trickery. I will show you. So if you add a decorator here, we can add a check gameplay tags on actor, which will check whether or not a given actor, which can just be one of the actors to check here, just any of your keys that are set to being an actor. It will check whether or not it has any or all of the gameplay tags that you supply it with. Now, you might be able to see that, hey, the ability system component is not actually in there, but we do want to check the ability system components. And there's just a little bit of weirdness here. Even though the ability system component is a component and not an actor, we're still going to make this key into a actor type key. And this will work. It will just look at it as if it is an actor. And now we are able to select that in the drop-down menu. And we can still set the value of this key to the ability system components, and everything will be fine. That just gives us an easy way in a behavior tree to check for tags that might have been applied or removed by the gameplay ability system. But we do also need to give that a value, so we'll copy over the set of value object node in our AI controller here, and we'll use the same Blackboard, and we'll make the literal name here ABC because it's ability system components. That's what we call that thing. And now we need to get a reference to that component to set the value as that object. And the best way to do that will be get controlled pawn. So this will just get us a reference to the pawn that we are currently controlling. And from there we can get ability system component. This is just something that you can do on any actor very easily. And if it has an ability system component, this will be the value of that component. If it doesn't, this will just return a empty reference. Okay, so that's the first thing that we can do with the gameplay ability system together with AI, is if we set this up with the ability system component as being a actor type key, we can now use the tags on it to drive some of the logic in our behavior tree. It's very, very nice. Now let's make a task for us to execute a gameplay ability. And I'm going to do this in two separate ways. The first way is probably what you're thinking about right now. So let's make a new task, call this BTT do ability, something along those lines. And this will be fairly easy. We can just say function, receive execute. The owning actor will get the ability system component from. And in there we will try activate ability by class, at which point afterwards we'll go into a branch, and the return value here is just whether or not the ability was actually executed. So if this is for any reason relevant information, you can use this to say, hey, if this was true, we finish execute with a success, and if that for any reason didn't actually execute the ability, we can finish execute with a non-success. Could be relevant in whatever AI you are building. And then we can simply just promote this to a variable and say this is the ability to activate. And if we make that public, we now have a task that will just execute any ability we put into it, or at least try to execute any ability we put into it on the enemies that are running this behavior tree, which is fantastic, right? So we can say we want to move to the player. But for instance, if we get within a certain distance of the player, we might want to do a ability. So we can say BT task do ability, and we can put a decorator on this which only triggers when we are within a certain range. So let's real quick make that, because it's actually remarkably easy to do so. So now we have that decorator here, and we can simply say the distance to allow is 250, and the thing that we're checking against is the player. So now it will only do this ability when this enemy is within 250 units of the player. And we can put any ability in here, even abilities that this enemy does not have. And that is important to understand, because you need to still grant the abilities to the enemy in order for it to be able to execute them. So the way here on begin play, we have this array that's giving the abilities, that's granting the abilities to our player character. In order for the player to actually be able to execute those abilities, you do need to do that for your enemy characters as well. So you need to either do something like this, which just is an array which goes through a for each loop that grants all of the abilities in the array to the character, or you need to make something that dynamically gives certain abilities at certain times. That is entirely up to what your game needs and what you want to make. You probably already came up with this being possible, right? So let's, instead of doing a ability by class, which kind of is limiting because now we necessarily have to make different behavior trees for different enemies with different abilities. But maybe we want to make one behavior tree that can just be like the normal basic enemy, but those enemies want to execute different types of abilities. Well, that is actually something that we can very easily do. And instead of doing the activating ability by class, what we can do is we'll remove all that, and we'll try activate ability by tag instead. This is very much something that you can also do on your player. It's less useful on the player, because usually on the player you want to execute a specific ability with a specific input and not something that is seemingly kind of random, but you can do this if it suits your specific production needs. This takes in a gameplay tag container. In our case, we're just going to promote this to a variable like we did before. We'll call this activate ability with tag. And what this will do is it will take any tags that you put in here, look at the ability system component that it's trying to execute this on, and check does it have any abilities with this tag. Because remember, if we open up just any random ability, let's just like do hero attack 1. In the class defaults here, the abilities themselves can have tags. This one is tagged as action.dash, which definitely probably is a bad idea because it's an attack, so we probably want to make something like action attack for this one. But you can make this much wider. So what we can do is let's just add a sub tag here to attack and say attack.magic and then even .fire. So now we can add that new tag, and we've got in our actions, we've got attacks, specifically magic attacks and specifically fire attacks. So if I have a fire spell for like 5 different types of enemies, what I can do is I can just all tag them as being a fire attack and tell this behavior tree through, through this ability to just execute a, in this case, a fire attack. So we can say action, magic, fire. And now we'll just look through the list of abilities that whatever character is running this behavior tree has and execute the first fire ability that it finds. And that is actually an important thing to realize. It doesn't pick a random one out of all of the things that fits the description. It just goes through in the order that you granted the abilities to the character and checks one by one, does this one fit the tag that I'm working with? No, I'm moving on to the next and the next and the next until it finds one. So if you have multiple abilities with the same tag, so if it has like 3 different fire spell attacks, it will always just execute the first one that it finds. So that is relevant. If you wanted to randomly take one of a few abilities, this whole tag system starts to work a little bit less in your favor. But now we can use this very basic behavior tree on a number of different enemies with a number of different abilities, and it will still work. So we don't need to split up our code through like 5 different behavior trees, the only difference in which will be the actual abilities that the characters are executing, because they can all share this behavior tree, because the behavior tree isn't actually saying what exact ability it should be executing. So that's been the gameplay ability system basics course. Maybe at some point in the future we'll come back to the gameplay ability system in a secondary course, which might go a little bit more into things like making your own gameplay tasks. Because in the gameplay abilities that we've been using so far, we've been using things like this apply root motion and constant force and play montage and wait and that kind of stuff. These are all tasks that the gameplay ability system provides you with, but you can very much, if you wanted to, of course, code your own. That's a little bit more advanced, and for the most part, I actually do think that the things that the engine just provides you with are going to cover you in like 99.99% of cases. So for the most part, I don't think it's too relevant to cover in this. Maybe in a potential future follow-up course to this, we can go a little bit more into depth with the AI. I don't really want to go too much in depth with the AI right here because it doesn't really add anything new beyond what I've shown in this video in terms of concept. But let me know if you do want me to cover something of that nature more in depth, just to see me going through it. It probably won't have that much new information to it, but it always could be useful if you want me to do it, to just take you through and make something with all of the information that we have covered in this series. So for now, that's going to be the end of this course, but there might be a follow-up course at some point in the future. I don't know when, depending on how much interest there is for it as well. So thanks everybody so much for watching this, and I will be back with some new content very, very soon. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,